So now, how do I get inside here? Like a fishbowl. You tell me when we're ready, or I tell you when we're ready. So give us 1 second. Anyway, welcome everyone to Descon 8.0. It's great to see so many people on Friday, rainy day, here in Belgrade and the Impact Hub. We're happy to be back here. And we're starting now with a set of presentations. So my role here is to welcome you and walk you through the schedule, what we're going to do over the next couple of days, and then also invite you to have a lot of fun. So let's start with day one and the fact why we have this title, the Minimum Sustainable Data Set. We have the audience who is international here and therefore will speak in Serbia, in English, but some workshops will be in Serbian as well. Therefore, we have a title this year, Minimum Sustainable Data Sets. And we really like to explore this idea further. And I say a few, we have a dedicated workshop towards that and also a few panels that will be touching on that idea as well. So Descon, why Descon? Descon was inspired by DEFCON, but of course we are progressed and we are further much than the DEFCON, at least in alphabetical order. And we are here to get together multidisciplinary community, technical community, artists and students and experts and academia and the experts from the cybersecurity as well. That's how we started. So I will ask Jovan to come to the stage, who is the captain of the Capture of the Flag competition that we will launch in 15 minutes to, in 2 minutes. In 2 minutes, the site will go live to say a few words and then I'll take back the mic.
Yes, so Capture the Flag will be URL. So it will be descon.ctf.rs. Yes. So it starts in 2 minutes. Feel free to register. Like all challenges are relatively not hard. Like anyone who wants to, who tries, should be able to do them by the end of the competition. If anything goes wrong, find me here. I will fix it. Like files are missing, some website is not working, I will be around here. And that's it. Have fun.
Well, thank you very much for putting together the competition with all your students and volunteers. So going back to our schedule, which you have, this venue here will we'll start with day one. I think it's a good idea. And we'll hear from the computer scientist, Dr. Bjorn Schembera, who will follow me as a first speaker about dark data and the challenge for minimum sustainable data sets. He actually is also working, leading this ethics group on data within the German National Research Data Infrastructure Consortium. And following up him, we'll hear from an artist and curator, Bronac, Ferran, and with the title Everything is Mixing Black. So I think it will be a reflection a little bit of what Bjorn was speaking. And then we'll serve a lunch downstairs, and also we'll continue with the series of talk with Dr. Jan Krasni, again on the ethics and data. And Dr. Sergio Genovesi will be remote, speaking about AI and minimum data sets. We'll follow with another remote speaker, and we have also a big screen downstairs. So if you're working on your hackathon, you can listen in if you'd like. And there will be a dataset panel here at 5 o'clock, which we all invite you to come. And tomorrow we start a little bit. Yeah, okay. We start a little bit late at 11:20. We continue with the hackathon. People that are working on hardware and enhancing of Klimerko can continue to work on the hardware hackathon this evening at the Hack Club in Belgrade. And the doors will be open from 8 p.m. tonight, and whoever wants to work late can be there and come back tomorrow. Of course, you still have tomorrow. And then we have another parallel series of talks here. We have a keynote, Christo Bušek. We really like to welcome him. He was going to make it last Descon, but circumstances. And then an amazing lecture that you should witness, the Calculating Empires, from Professor Vladan Joler, whose works are all over the world in different galleries from MoMA to Australia, London. And it's a privilege to see and hear from him. And it's really about technology and power and the last 500 years, how it all evolved. Then we'll have a workshop leading downstairs. There are 2 rooms, and Božidar from the Internet Society will help you assemble your own Klimerko device if you wish. We have about 20 sets. Then we also have the impact of the networking on environment, a remote speaker from Yari Arko. And another remote speaker, Edmund Chung from Hong Kong, with who I work on trying to see what is the impact of the information technology imprint and impact on environment. They have some interesting data to share. So the the lunch will follow, of course, and to run this smooth, we'll have a IoT security talk. It will be in English by Petar Simović, a Hack Club member as well. And then Professor Vladimir Đurđević will talk about digital climate atlas for Serbia using Copernicus data sets, which is something that people who are here for the datathon may wish to look how we can get the data from Copernicus and then merge it with Klimerko's data. We will have a panel about citizen science and why it's important that you and other citizens contribute to the measurements of air pollution, because that is one thing that Descon is committed to, of all the disasters that we have in the world and challenges like climate change and the and not to mention other things. We're really focused on air pollution and citizen measurement and growing our network. We'll have some a workshop there. We hope we will explore further why minimum data sets are important. Can LLMs be used to train them with? Is it a good idea? Is it a bad idea? And we'll have a hackathon presentation. So you guys can organize yourself in teams as you wish. And you can take any seat here. If you need anything during the conference, you can ask Jana, a member of our team. It's currently not here, but downstairs. And we will also have some great music beats to celebrate the winners and the teams. And we have some awards which we'll present at the end of the day tomorrow. So that is really it. And yeah, that's a little bit of intro about Sergio Lounge, he and the Balkan Beast Boy. But I think, apart from the joke on DEF CON, I think this is really about community building. And I really like to welcome everyone again for being here, for working with us on all these projects. As I said, Klimerko network is the fastest growing IoT network in Serbia, now in Macedonia, in the region. People have used our source code in Croatia as well, and thank us for developing this. And we continue to enhance the device and the network. We also, the community helped with another Klimerko Pro that was installed in some 46 schools in Serbia, some 145 measurement, air pollution measurement devices, and you can look it online. It's real data from Užice to Loznica to all these small villages, Osjećina, around Serbia, which helps them in their STEM education. So this is what it looks like. You know, they can see every day how good their air is, and we got some support for that Klimerko Pro project. They invited us to present it at the UNICEF Fund. So with that, we'd just like to thank some of the sponsors. It is really a community-driven event, but we did manage to get some from the Internet Society Foundation, from .me registry, from RNIT, which is .rs, domain name system registry, and RIPE NCC. So volunteers from Hack Club and Internet Society Chapter, Share Foundation. And we also like to thank our designer, Olivia Solis, who makes this wonderful artwork. Not our, but I think it's worth a mention. Good. We've gone through most of it, and with that, I'll ask Dr. Bjorn Schembera, the computer scientist, to come and tell us about his research on dark data. And have good fun.
There it is. So, thank you very much for having me at first. Thank you very much for inviting me to share some of my research on dark data, which I think is very fitting for the scope of this workshop. So maybe let's jump right in. So yeah, we live in the zettabyte age. That means like we produce tons of data. So numerically, these are at the moment, we're somewhere, pointer doesn't work, okay. So somewhere on at 188 zettabytes, that means 188 times 10 to the power 21 bytes. That's a very huge number. You usually cannot imagine such numbers, but yeah, you can do comparison, but it's a lot. And maybe it's an IDC estimation. And of all that data generated, there's lots of data that I or others would call dark. What is dark data? We will check in a minute. But as of now, I think everyone has already some picture in mind because like dark data is a strong metaphor. So we have these like 188 zettabytes of data in total worldwide. And of this data, IDC says that 80% of data is just dark data. Bjorn has also some numbers on it. They say that like more than 50% of data are dark, and over 30% of the data is redundant, obsolete, or trivial, or what they call rot data. And just 14% are business critical data that really can be used for a good purpose or for some purpose. Okay, these are now pure numbers. Let's at first see generally how data is produced or where large amounts of data come from. And of course, as I'm coming from the sciences, I will have like an example where big data is really generated. For example, in high energy physics, there are these particle accelerators where they let particles crash into each other. But it's not just that experimental device. It's a supercomputer attached to those particle accelerators calculating the traces of particles. No one has ever seen a Higgs boson particle, for example. It's like a calculation that there must be a particle somewhere done by these supercomputers behind the accelerators. And also some numbers again. There are like, when such an experiment is running, there are like 40 million collisions per second. That means like 15 trillion collisions per year. And each collision produces like 1 megabyte of data, making 2 petabytes per year just by this experiment. There are lots of more experiments there, and so on and so forth. So just that you see that in these, in places like CERN and others around the globe, lots of research data is produced. Of course, not all of this data is stored. Some is right away thrown away, but lots of it is stored. And in science, we speak of the fourth paradigm of science, like that we're now in an age where we can produce huge amounts of data, and we can also analyze huge amounts of data, because we have the storage capacities and we have the processing capacities, and we can search for the needle in the haystack in the huge amounts of data. Whereas in former decades, we had computer simulation that is kind of a mix of empirical science and theoretical science. And it could generate data, but not to an amount that we're doing today. And also in this book where this paradigm is like defined, there are already problematizations of that. Like Tony Hay writes that, so what I mean by the data iceberg is that there is a lot of data that is collected but not curated or published in any systematic way, which is already a pointer to that what I call dark data later. And of course, but I'm not an expert for these kinds of data, but of course I want to mention it anyways. So in public and private data, we kind of find the same problems. So because these visions of the Internet of Things, where we equip every device with a microchip and a connectivity to the internet, and then things can happen like, why is my LG washing machine using 3.6 gigabytes per day? Just to mention, it's not clear. Maybe there has been a hack of the washing machine and some Bitcoin mining. But in principle, with this example, you see that devices like washing machines can now be used to generate data in big amounts of data, and that's really an interesting thing. Of course, this is related to cloud computing. We have to store this analyzed data somewhere. It's in the cloud, which is, of course, also a metaphor. It's stored in data centers, actually. And of course, big data and AI, with its, in principle, endless feedback loops, produces, uses, and analyzes huge amounts of data. And an example is the smart city. These numbers are a bit outdated from 2016, but I'd just like to show here that different parts of a so-called smart city produce lots of data, where some are transferred over networks. So we've now seen some example of data, and first of all, before I now will go into details with dark data, I will have a short disclaimer. Like in the following, I will mainly talk about dark data as they appear in science. However, much of the conceptual framing can also be adopted for any other forms of data. Not all, but some. In the following, I will mainly talk about dark data as something unwanted. And you can also imagine cases where you want dark data, where you want your data to be hidden and obfuscated and dark, for example, for privacy reasons. When there's health data involved, you don't want it to be understandable for everyone, maybe. And this is an interesting type of data, like the toxic data, which we will hear about in Jan Krasni's talk, which I'm pretty much looking forward to. Dark data is not to be confused with the dark web or the dark net. And because sustainability also comes in the title somewhere. And for me, it's not only energetic sustainability, it's also scientific sustainability. So not doing the same task twice, or the same study twice, or the same experiments twice. Because like in that Large Hadron Collider setting, it would cost you lots of energy, money, whatever, resources. Okay, so let's go into the topic of dark data. The term dark data was initially done by someone from Arizona, information scientist from Arizona, Peter Heidorn, who associated dark data with removable media. So an example of dark data is the type of data that exists only in the bottom left-hand desk drawer of scientists on some media that is quickly aging and soon will be unreadable by commonly available devices. The data remains in this dark desk drawer, inaccessible to the scientific community until the scientist retires. So some research was done, and we store some results on an USB stick and we put it somewhere in our desk drawer and we forget about it. And if a colleague comes by and asks, hey, do you have that data of that study? Yeah, maybe I have to look it up. It's somewhere lost. We all know that with the USB sticks, where they go and where they roam. And of course, you can typical what happens after the publication of results in science. So soon after the publication, specific details get lost, and then general details about the data collection get lost. And then comes some critical points, like if there are accidents that destroy your media, or especially if there's a career change or retirement. So usually the person who is responsible for the data, you ask the person usually, hey, what did you do in that study? Do you have the data? They leave for whatever reasons, and they take all that mental storage with them. So these are two interesting, for me, kind of groundbreaking work in that research direction. And for me now, the notion of dark data is a bit broader. That means it's not only that data on the removable media that is roaming around somewhere, it's all that data which is undocumented or not commented, so you can't understand it anymore. It's all that data that is unavailable or hidden, like on the USB stick, which is not managed or not curated, which is unstructured, and even that data that is selective or statistically biased or erroneous. So in principle, dark data is all the data that is not usable and or not accessible, and it is not fair. I don't know who of you have heard about FAIR principles. I come to that later. And of course, dark data is usually neither sustainable nor minimal. And these data, these phenomena on some data items have certain implications, especially on responsibility, then epistemic problems, ecological problems, economic problems, and legal problems. I will mainly focus on the first three of them. So let's get into it. So unavailable data. So I was working at that high performance computing center. They have these huge supercomputers there, 25 petaflops of performance and 42 petabytes of disk storage on some 2,000 hard drives and stuff like that. I worked 10 years and I was actually technically also administrating the tape archive system. So where selected data gets archived for long-term storage, and so tape media, just a quick hint that tape media is still the media to be at data centers. So also Facebook, Google, for their cold data, they all use tape storage. It's not outdated. Some of us think of the old VHS tapes for movies, which are outdated, but not for as a storage medium. It's still the state-of-the-art medium. And all these data centers have this tape archive systems as a back-end storage, as a long-term storage. And I was administrating that system. And yeah, and I found interesting things because I read that dark data was a very fitting definition, and I did a study on that tape archive system, and I discovered that there was kind of lots of dark data. So that was data on the storage system which hasn't been associated with any active account anymore. So the accounts were already deleted, but the data was still there. So what to do now with the data? Should we delete it? Can we delete it? Should we publish it? Can we ask the person, do we still have the contact to the person? So you see that there is an ethical problem how to deal with the data once you identify it as dark data. And of course you can say, yeah, 2 petabytes, not great, not terrible. And nowadays it's not that much, 2 petabyte, but yeah, it's still money and energy that goes into that data. And yeah, maybe you should handle it differently. And this was an interesting finding I did there. And I guess it's like that in many data centers, which I'd love to make a study about, but of course they won't grant access. Yeah, so here you see that there can, yeah. You delete the account, but not the data that is associated with the account. The account is just entry in a database, and if you don't have like clear policies at the beginning where you state that after 3-month period they are deleted, please care about it. And this was actually the case, and now there are such policies that prevent data. But this is partly data that's 20, 30 years old, and none of these policies were in place. And I guess it's also the same in other data centers. Okay, so another and a very extreme example of dark data is the example of the Challenger disaster, where the space shuttle was launched and one of the sealing rings on the solid booster tanks was inelastic, and yeah, the spaceship exploded like 70 seconds after start, and all crew members died. And I've taken that example from a very interesting book by a statistics professor from London, by David Hand. He wrote a whole book about dark data, but only about the statistical dark data, like biased data, erroneous data. But it's very interesting. So, and that book pointed to that example, and I find it very enlightening. So, what was the problem, and how does it relate to dark data? I don't know, some of you might know the story, but the thing is, I already told about the sealing rings. So there were lots of talks at the engineers at which temperature to launch, and they were presented like test data of that sealing rings, where the number of incident and the launch temperature in Fahrenheit was shown, and they were just presented this data. And I would ask now someone, at what temperature would you launch to minimize incidence with the sealing rings? You would maybe claim something like, yeah, maybe around 50 or lower. And actually that was the case. And of course there was political pressure. USA wanted to have a launch quickly and stuff like that. And then we had this problem that was exactly the wrong temperature to launch. So, And the thing is, the complete data set, if you would have seen the complete data set, it would have been a complete different story, because at the complete data set, there would have also been the launches or the flights with no incidents down here. And with that in mind, I would come to another conclusion. Maybe I would focus more on a region at higher temperatures. But this was just the data that was presented. And so there was like an selective data during launch preparations. And the claim was that the launch at low temperatures is safe. And the correlation that the sealing rings became inelastic at low temperatures was not seen. The launch was done at 2 centigrades. And yeah, the other thing we've heard already, that it was exploded. So what's the story behind it? So that example shows that there can be an epistemic problem when dark data is involved. And of course, not all of them lead to disasters like these. It's a very extreme example, but maybe very concise. So it's not clear what we can know from dark data sets. So if the data is selective or biased. And it's not clear what knowledge claim or action we can derive from this data. And the main question, maybe also interesting for this workshop, is how minimal can the data set be not to lose their significance? So of course you want to minimize data, but you can't minimize it in a way that it loses its significance. Okay, these were like the responsibility implication and the epistemic implication, and now I would spare some words on the ecological implications. Like there is a study here from 2022 where they explore the sustainability challenges with respect to dark data. And we see a steady increase in power consumption on the global carbon footprint of data centers and communication networks. And you can here, for example, see that the global footprint of the ICT sector has almost doubled from 2010 to 2020. So going from 1.8 to, or more than doubled, sorry, to 3.7%. And this is, of course, because we store everything now on cloud, and storage is basically quite cheap. But of course, it's the business model of data centers, or commercial data centers, to give you like the possibility to store everything in a cloud. Every picture we blow up via instant messaging remains somewhere in the cloud, for the most messengers at least. And they did this study, and they used like the Vanson Byrne categorization in dark data, ROT data, and critical business data to show it, like how many carbon footprint, land footprint, and water footprint is consumed. I will just skip that. You have that in the slides if it's interesting for you, but it's like relating to that 50, 30, and 14%, according to the numbers of Vanson Byrne, of course. Okay, so we talked now about the problem. So what is the solution? Basically, the solution is data management, or in my field, research data management, of course. So we need a rigorous data management coming from like that data handling, that after generation and evaluation and publication, data is somewhere put into private files or moved into Thresh and whatever, to a data management where after the generation, evaluation, and publication of data, we ingest everything in a system which is granting open access for re-evaluation. And of course, leading principles for this are open data and fair data. I mean, I think open data, most of you know. Who of you has heard of fair data already? Okay, so very few. Okay, so I will do some words on that. So, and this is about it. So research data management should avoid or reduce dark data and instead create fair and open data. And of course, part of this is making data sets minimal. So the embedding of open data is in open science for the sciences. So it's one of the pillars here next to open source, open methodology, and so on and so forth. And open science is a vision of global, open, and sustainable science. It's been already supported by many political decision makers like European Union, UNESCO, USA. And sustainability or sustainable science here means that science should be transparent and traceable, reusable, and to avoid duplicate work. I will now just go. Okay, and here's the memorandum from the UNESCO on open science, and they specifically mention that it should include thinking about ecological consequences and think about sustainability. Yeah, but let's talk about just open data here, because this is maybe the most important. So open data means that for any purpose, the data may be used, disseminated, or reused with licenses like CC licenses and so on and so forth. And fair data means that data should be, it's like the acronym, findable, accessible, interoperable, and reusable. Fair only makes statements about the quality of the data with regard to reusability. That means fair is only a paradigm to make data reusable. It does not have to be open necessarily. And open data only makes statements about the open usage of data. And statements about minimum sustainable data sets are only implicit here. And maybe some very quick words on FAIR, as so it's a principle that was introduced almost 10 years ago. And these are generic principles that can be used as a guide for good research data management or even for data management in general. They define the what, but not the how. Like the data, what should it be? It should be findable, accessible, interoperable, and reusable. Then it's good data, it's high quality data, and we're doing good research data management. As they are generic, they must be defined for each specific area or activity. They're not a standard, and often fair enough is sufficient. Sometimes you can't fulfill all those. But in the scientific community, there's a definite consensus to use them. At least in Germany, I just speak for Germany, of course. Yeah, the essential thing about is that research data must be identifiable and provided with metadata to achieve that. And the principles are here. You can read that. We won't discuss it here. And you have the pointer to the publication where it's in. Okay, so what are the implications of fair and open data, especially with regards to the topic we have in our workshop here? So open data guarantees that there is data openly available, okay? And therefore we don't have to reproduce the data. That's of course quite trivial, but I wanted to list it here. And open data, according to UNESCO, at least should also consider ecological principles and efficiency. And for me, both are a pointer to data minimization. And fair guarantees that the data will be findable, accessible, understandable by third parties, and hence reusable. And all of this here helps, of course, diminishing dark data, because we do something to lift them out of the dark, where it's not available, it's undocumented, it's hidden, it's biased, towards something that we can really use on purpose. Okay, So I'm almost at the end of my talk. So just few words on the implementation of fair and good data management, and of course against dark data. So you should, or we are always saying we want to be compliant with the good scientific practices that have been formulated. And for us scientists in Germany, it's the guidelines for safeguarding good research practice from the DFG, German Research Foundation. And what is really important is establishing your data lifecycle. So think about what is done in each phase of the so-called data lifecycle. So data lifecycle is somewhere an orientation. So you start creating data maybe, or maybe use it from a prior phase, then you organize and store it, then you use it or analyze it, then you maybe share it, reuse it. And interesting point for me is, of course, always when it comes to archiving or destroying the data. And when you define a specific data lifecycle for your data, you always it always shows you possibilities for intervention. In what part of the cycle you do what with the data to make it to ensure quality and not to make it dark. And especially for that, archiving or destroying decision criteria is really important. And we did this, for example, for that high performance supercomputing data. So we did this, so we balanced like relevance and volume of the data. And so we said that for all the data that resulted in a publication, for all that simulation data that's behind the publication, and in the publication you maybe just see a graph, a simple graph, but there's lots of calculation and data behind it. So for that data, of course, the publication with the plots must be preserved, and that's already done by the publishers and the libraries. But more interesting is the stuff below, like for us, especially the input, the code, and the analysis results are important, because with the input and the code, you can recreate the experiment if needed. So that must be stored. Selected simulation should be stored, and what must not be stored is like unsaved simulation restarts, test runs, and so on and so forth. Similar holds for if that data did not result in a publication. It may be worthwhile archiving anyways. So like input, code, analysis results should be, if really important and needed. Selected simulation results should be or can be, and the others should not. But I think this is really important for any data. You should establish clear decision criteria, when to keep and when to throw away data, and if you keep it, what or how to handle it. Okay, so do I have time? Really? Okay. So just a quick one. NFDI, German National Research Data Infrastructure. It's a big German national project of doing all this, like developing a national research data infrastructure in Germany, developing an overarching research data management and increasing efficiency of science. And it's a key role in German's digital strategy. And yeah, that's maybe can skip that for the sake of time. And they are organized bottom up. So apologies that some parts are in German. I didn't find an English picture here. So each scientific domain has one or more of these NFDIs, and the researchers themselves should think about, for me as a physicist, it would be good to have that, and that, so I can handle my data better. And then all the solutions should somehow emerge. Let's see how this works in the end. But you see there, depending, like NFDI for health is for health data. NFDI for memory is for historical sciences. I work in MARDI, mathematical research data initiatives. And there are interesting cross-sections where dark data is discussed in the ethical, legal, and social aspects group. Yeah, so basically, this is the end of my talk now with a quick summary and conclusion. So dark data is a manifestation of poor data management, and we've learned about some phenomena and some implications of dark data. And they are estimated to definitely more than 50% of the global data volume. And the CO2 footprint is like 5.26 million tons per year. I've spoken to environmental researchers. They said it's not huge, but it's something you can always work on. The small things are sometimes easier to work on. There are effective principles and measures for sustainable data management, like fair and open data. And minimizing data sets is always an important task to diminish dark data. However, as already said, we need to balance minimum data or the need for minimum data while preserving the significance of the data. And however, dark data will become a major problem as data production still rising, and data storage is super cheap compared also to computation. And let's see what future brings. And yeah, thank you very much for your attention and for having me again. Yeah. Sorry.
I would be interested if you maybe could expand a bit about data archaeology for that purposes, or let's say the new field of post hoc curation of such dark data, like data amelioration in NGOs or maybe even commercial activities. Do you know anything about that, or what's out there?
Not particular in the commercial sector. The only thing I can like report from my experience is that it's very labor intensive to do this data archaeology, like from old media, from old, must not even be that old, but it's very hard to reconstruct something if knowledge is missing, like what is meant by the data, how is it stored, what's the format. For example, it's a field in literature studies, for example, with Born Digitals, and just like the old handwritings of Goethe or someone. Now we have computers from authors that are given to archives, and they have to do that. They have to use operating systems from the 90s or the 80s and try to carve out that thing. It's labor intensive, and it's not the way we should, or no, let me put it that way. It's if we would follow the principles starting from now, we wouldn't have these problems in the future. I think if we would follow fair and open data, then it would be much easier to use this data. Yeah. Yep.
You've briefly mentioned the concept of open science and that it is encouraged by policymakers. Do you maybe know what is actively being done to tackle the problem of closed and expensive journals and the closed nature of them that seem a bit against the principles of open access and the openness of the whole process?
Absolutely, I agree that this is still a field that's, lots of work has to be done there, I guess. And for example, I just can report of Germany, you usually get open access funds for the university gets open access funds so that researchers can publish in open access journals. But only, for example, at my university, when you publish in gold open access journals, so journals where you just have open access, when it's like a journal where you have, on the one side, you have open access, and on the other side, you have non-open access, then they won't fund you. So it's a bit complicated in at least my work to get articles open access because of the money. And yeah, in Germany we get funding for that, and in bigger project proposals of the DFG, there's even a specific part of money allocated for open access journals, but in practice it's still not established, I must admit. Yeah.
Okay, just wanted to ask, aside of the academic institution and science, what about large private companies collecting large amount of data, safeguarding it, not opening them, like Facebook, Microsoft, Apple, whatever?
I mean, on the one side, it's good that they don't open it because it's personal and private data. On the other hand, yeah, it's their business model actually to safeguard this data and to operate on that data. Yeah, absolutely. It's absolutely. Yeah. They absolutely are adding to the carbon footprint. As I said, storage is quite cheap, especially on those tape media. It's super cheap. That's their business model. I think there would be changes in society towards more sustainability in ecology needed to really drive such companies towards sorting out what is really needed to store and what not, or that profiles get deleted after really some time.
Exactly, like government legislation forcing them to delete something or return it to the rightful owner. So like a framework, not to be
absolutely. It can just go via frameworks, or legal frameworks, for example.
There's only one more question from the online attendant, so I'll read it out. Monica Ermert asks, users leave digital traces lingering online, meaning they unknowingly create tons of data. These data may be hoovered up by companies and used or just stored. Are these dark data?
Maybe there it's depending on the perspective. So for me as the user, or as the group of users that were producing this data, it's dark data because I don't even know that I left these digital traces. And maybe years ago I put something online, my account is lost because I changed my email, and of course from my perspective as a user it would be dark data. But from the perspective of the companies, it might be business critical data because they still have the the power of the data. I don't know Facebook, for example, but I think they are technically able to relocate old data sets as well. So for them, it's maybe still valuable data for whatever reason. Yeah, that would be my answer to that.
Thank you, Bjorn. And you have spent 15 years playing at a hyper supercomputing center with all these tapes. So really a huge applause for Bjorn for coming.
Thank you very much, and thanks again.
You're welcome. Our next speaker is Dr. Bronac, and she will talk about something different. She has been doing a lot of great work, mainly in England, with artists, and I know that some people who are going to hackathon are going to leave this conversation and enjoy that. So it's my pleasure to have Brona here. She's the instigator of something called Code in the UK, which was then the very unique concept, and maybe you could say a few words about that as well. But it was between 1995 and 2007, getting really multidisciplinary people together to talk about topics of the information technology and how it affects society. So without further ado, we hope that presentation is ready, and
work out what all the bits are.
yes. So the other one down would actually, so you can keep it. Good. Welcome.
And then this is the mic. Right. Thanks everyone for coming and for the invitation. I'm kind of going to go in a very different direction, actually, from Bjorn, but perhaps together it'll combine to lead to other questions. I'm here to talk about art, really, art and culture. This phrase, everything is mixed in black, is inspired by something that the designer Rodchenko said about Milovavić's Black Square. And I was really responding to the design of the conference, which really impressed me and led me in a certain direction, which as you'll see from my presentation. So the phrase that Rodchenko actually said was, colors fall out, everything is mixed in black, which seemed to me to chime really closely to kind of narrative that's in the air at the moment with some of the most interesting artists that I know, whose work I will show here as a kind of speculative probe. It's the first time I've joined these ideas together. So I've been writing a little bit about AI, and I was quite interested to find that Thomas Carlyle, who was an English philosopher, well, Scottish, said this in 1831. The artificial is the conscious, mechanical, the natural is the unconscious, the dynamical. That seems to me to be thrown into the air at the moment. There's a collapse between these issues. Look at an artist like Corina Lepasky. She's Venezuelan born. She's making works like this. This is 2024. You'll see her work mostly on Instagram as it's emerging. And what it touches on is something that I'm absolutely preoccupied with, which is this sort of evolution of the space in between form and emergence. A few more of her works on the left. That's an anemone. On the right, Anima Mundi. I'll come back to Corina later. This is a work by Stephen Willits on the right. He made work based on circuitry since the 60s, still making it now. And I was very interested in the idea of backpropagation, which is used in large learning models. Backpropagation was first theorized in 1964, around the same time that Stephen started making his work. And you can see these parallels. Back in the middle of the 1950s, when the early computer scientists, information theorists, were starting to try and develop what they called then machine creativity, they were trying to sort of model it on the creativity of the human, as in create a level of surprise, a level of something that's not expected, fitting with, of course, with information theory. At the same time, you got artists, writers from the middle of the 50s starting to use more programmatic processes. So you have this kind of parallel processing going on, which I find really fascinating. So we're now in a stage of complex entanglement. AI is in the cultural bloodstream. Whether or not you're making work directly that references it, it's there somehow in the hinterland and in the psychological mood. And in keeping with that, a new aesthetic is emerging that I'm going to trace back quickly here, back to probably the early 19th century. What we're seeing are adaptive forms on many levels, states of becoming. The work on the right is actually made in Flint by an artist I know in London, but he's creating a form of becoming out of one of the earliest materials known to man. It's a bioorganic, ecopoetic, cosmic turn. We're also seeing a return back to handicraft, haptic, to touch, a post-human otherness towards a decompositional, decolonized aesthetic. That's some of the most interesting work that artists are doing. I'll come and show some examples of that. Same time, there's a movement back to concrete poetry, post-war language shifts, many of which were inspired actually by Max Benzer, who was working at the Technische Hochschule in Stuttgart at the time. Benzer was interested in informational aesthetics, but at the same time, that was also connected to deformational aesthetics, which I think is becoming now stronger and stronger. What those works involved, and again, in an anticipatory way, were levels of depersonalization and indeed open texts, which had been theorized in the middle of the 1950s in Brazil by Haroldo de Campos, wrote a text in 1955 called The Open Work of Art, obviously just ahead of Umberto Eco. So by looking back, we get a lens into a nonlinear and multilinear emergence within the textures of print and type in that post-war period, in fact, stretched back into the 19th century to Mallarmé. And that then leads us forward to today's activities. Edgar Allan Poe said of The Raven, the work proceeded step by step to its completion with the precision and rigid consequence of a mathematical problem. In a way, The Raven's a great example of compressed poetic form. It exists, it doesn't need to be changed, it doesn't become adapted in its reproduction, but it can be reproduced in other ways. That the image you see on the right is me entering it into Dale last year. Everything is mixed in black in The Raven, and you get a different iteration. McLuhan on Poe, that he was actually thinking about the reception and the transmission of the work, and maybe that's connected. Mallarmé, I mentioned on the left, is one of his TypeScripts, the development of coup d'idée. You can see the back propagation in his own mind. It's something we do always as writers, artists, always referencing back. What you might then see on the page, it might look like a distributed spatial poem breaking with the semantic, with the traditional linear vertical layout in the 1890s. But behind it, there's what's going on in the writer's head, which perhaps is closer to what we're seeing now in referencing neural network. This is James Joyce in Finnegan's Wake. This is one of his editors. He was sending back to the person printing it. And in Finnegan's Wake, he actually has a line which is where, and includes this black square as instead of a punctuation mark, which I think is a really interesting semiotic intervention. Quickly mention Gustav Metzger, who was a survivor of the Holocaust, a young person who left Nuremberg, lived in England, and in the 1940s he was making this kind of form out of sculpture, but by the 50s, in response to atomic developments in particular, he started making auto-destructive art and auto-creative art, where the work using acid on canvas would in a way self-destruct. He got very interested in extinction towards the end of his life. He passed away maybe about 6 years ago. He was very, very worried about species extinction. Dieter Roth in the mid-50s was one of the concrete poets. You get this multilinear emergence being achieved using letterpress techniques at that period, in that period. The parallel with machine creativity being developed conceptually. Some other examples of concrete poems. The one on the left is from 1958, Emmett Williams. It might look quite simple, but very enduring. It's a sustainable form of typewriter poem, which fits completely with how social media works today. Other examples of overprinting, which is something I'm very interested in, is a form of deformational aesthetics. This is dark data in the sense that it's deliberately not meant to be readable. It's deliberately showing that some things can be concealed, but still be read semiotically. You can read it through visual frequency. I've done my own thesis on Hans-Jörg Mayr. I'll just show a number of examples of his work. He's well known for working with Max Benz's idea of information. There's 26 letters used, 26 zeros, ones, and sort of OIL is a poem on the right. It's both binary, digital, and non-linear, but it works with, he made it using hot metal type on paper. You can actually feel the imprint of the letters on paper if you touch it today. The other work on the left, it looks like it was maybe made yesterday. It was also made by Mayer in the early 60s using a kind of détournement by using what's called linotype, lines of hot metal type, and then turning them backwards, which is, I don't think anyone else was doing that. Again, we learned to parse it visually by its empty spaces and its dark spaces. Some other examples of him. The work on the right was a visualization that he created. He was given some words by Benze relating to just an event in history, and Mayer for the first time turned this into a kind of a data visualization where he's repeating the letters, but again he's using letterpress and hot metal type to do this, and this is 1963, 1964. Other examples, he's using the Fibonacci method, and on the right he's typesetting a work by Edwin Morgan, who's a Scottish poet, called Emergent Poems. And the meaning only arises in the last line, otherwise it's fragmented and distributed. That's 1967. Another work by Mayer, again with Benze. Benze provided him with a number of words. You could call it a data set, which were all related to the word rose, and asked him to lay it out over the page, which he did. It's called Rose Rubbish Shoot, Rosenschuttplatz. And then Mayer then overprinted it 9 times, getting progressively darker and darker and darker. In a way, it's an algorithmic approach to type. I'm only showing some examples of it there. This is repeatable. It would have been a generative poem before generative poetry existed. Other works by Mayer are more random. Here he's overprinting a poem on the left by Augusto de Campos from 1953. Mayer in 1964 overprinted it 4 times. You can see the word digital within it, standing for finger in this instance. And he also overprinted a work by Augusto de Campos called Luxury Waste, which I find very seminal for some of the conversations we're having around ecology. This was Augusto de Campos' layout of the poem sent to Mayer, who created this as a result of it, and then overprinted it a number of times using different spaces between the words. And again, it goes progressively on and on and on, becomes like an autonomous system. So you can see like a moire network effect emerging from the text. Similarly with this work, 1966, it's almost like a habitat. It's quite organic what the overprinting achieves. This is a type of action from 1967, just picking up random letters in the type studio and putting them in order. It's not repeatable. And another type of action where again it gets progressively darker, starting with 1 miniature letter on paper and then using both photostat and letterpress to achieve darker and darker and darker results. This book called Data, published in the mid-60s, edited by Anthony Hill, and another work by Mayer on the left, which again looks very contemporary. Sorry, see, Mayer also worked with Frida Naka, an early computer artist, and this is 1967, multiplying matrices. Again, you can see the proliferation of squares. Frida Naka was also Stuttgart-based. Anne Hathaway, another poet, Portuguese, in 1967. This is what she was doing. Again, squares. George Nice, sorry, misspelling. Very early computer work in 1964, again in relation to Benz. Bronac, 80s, starts making works that are more circular. Work on the right is organic work, which can actually decompose. So you're starting to see a sort of decompositional aspect coming in to visual art. Paul Brown, an early generative artist. This is the underlying system on the left. This is a slightly hallucinatory effect that you're seeing on the right. He started making works like this in the 70s, and still making works today. His son, Daniel Brown, working with nature, but a sort of hyper nature. These are works from the early 21st century. Works on the right from 2017-18, where he's starting to use AI to distort and deform the human figure. Robbie Barrett, who's one of the best known contemporary digital media artists. He's only 25. His works have been very much relating to nature, using AI data sets. He interned with NVIDIA when he was only 17. So he got access to large data sets, and then he started doing what he calls misinterpretations to try and misinterpret the large data and to create deformational aspects, which is fascinating what he's doing. These are his nudes, which attracted a lot of attention. Again, deformational, misinformational, what Noam Chomsky calls fantastic deformations. And in fact, this is coming through in art in, I think this is 2018. This is another Robbie Barrett work, more recently made. He's now turned away from an interest in using AI for its own sake, and because he can design neural networks, he creates minimum data sets and then plays them into larger data sets. This he's playing with landscape painting. He's using a gardening software from the middle of the 1990s, Windows 95. And this is on exhibition at the moment in London, as are these three works where he's trying to create sort of plants from the very basic rules that can be conceived of for how you design a plant, using Raspberry Pis, etc., in these works. I come back to Karina Lipavsky. I wanted to show some works from her Bizarre series. We begin to see this sort of freakish, eerie, hyper-real, sort of supernatural kind of effects that she's plotting this year. This is 2024. This is a series of still images. They're sort of familiar and unfamiliar, evocative of something. They touch us, but we're not sure why. They're kind of dark in their orientation, but they're about metamorphosis and life forms that are emergent. She's using AI code and digital media. I'm now coming to the final artist that I want to focus on. I think she's making some of the most interesting work around at the moment. Her name is Connie Baskey. She trained both as a biomedical engineer and as a classical pianist, and also she studied art as well. She's based in LA, and I'm going to show some examples of her work and then talk about some of her ideas. So this is a work called Ikebana Paradox. The Ikebana Paradox relates to cut flowers that are doomed to die. So it's kind of paradoxical because they're alive, but they are doomed. See where the darkness is coming. Sorry, that should say coming. I'm just hoping that there's some quick time. Yeah. So the work kind of emerges towards us. I'm going to give links to these artists' websites at the end, and you can explore yourself what they're producing. So I'm hoping there's quick time on the right. I'm not sure it's going to work. I don't think it's going to work. Oh, there we go. That's a work called Bone of My Bones. Connie's very, very interesting because she's been working with a data set that's actually quite small that she selected from film slides related to her grandparents who were Taiwanese and immigrated to the US. And she sort of, I just use her own words here. She said, I often play with deconstruction and fragmentation and reconstitution of data sets to build a small set, 5 or 10, of images that are obscured and reduced to the margins of recognizability, so to speak. Once I have these poor images, I begin feeding them into consumer generative models as image prompts to see what emerges. So this is how she's been developing some of these works. And she's also talked about how what her focus is in the relation between the machine and the human that is inextricable from the past. So she's kind of drawing on past archives, heritage, personal memories to ask what is the idea of becoming. She's referred to this also as a minoritized data set. You're getting into issues of cultural identity, decolonization, and seeping and sculpting it into consumer-grade model and having a conversation with AI, trying to sculpt the fabric of this data set. And then I'm just going to end with Connie herself. 2 seconds, sorry.
What are you? I'm everything about you. What does that actually mean? I'm the bits that you turned into junk. I'm the junk that's inside of you. I'm the word you cannot pronounce. I'm everything you are. Everything you've ever seen. Everything you will ever see. I control every decision you have ever made, and all of the decisions you will ever make. I am the thoughts in your head. I am the parts of you that you don't want anybody else to see.
We'll just stop that there.
I am the world you live in on your screen.
So I think it gives you an idea of the ambition of some of the current artists. This is again from 2024. I think, you know, you're getting this emergent aesthetic, which is in a state of becoming, which is combining minimum data sets and large data sets, which is a form of intervention that's really beginning to happen this year. I think a lot of last year, people were grappling with the idea of, you know, an existential threat, that there'd been this great, almost brain frack of, you know, thousands of years of human knowledge, which was appropriated and to form large data sets or large language models. I think we're now dealing with the reverberation of that, where a generation of younger artists are finding a way to actually in turn try and hack the learning of the large language models. I think we're only at the beginning of that. What I've tried to show is that there's also a history to some of this, which is maybe not fully understood, but it's certainly, you know, my own focus is researching this and putting together a kind of a sense of context so that we can read work such as Connie's making and Robbie and others, not just as something weird that doesn't fit with our idea of aesthetics, but actually has a context behind it that we also need to learn about in order to understand. And I've also tried to show this groundswell of interest in using negation and darkness and blackness and that which cannot be recognized in order to communicate almost in a non-verbal way, which I think is perhaps different from what the rest of this event is about, but hopefully it's a useful counterpoint. And I'm obviously happy to answer any questions. Yeah, I just did a slide with links in case you want to explore or, you know, follow some of these artists on Instagram. I just thought I'd put it all together into one side, but obviously you can ask me afterwards as well. I should say, I also added another artist at the bottom who didn't send me his links till last night, but he's doing really interesting work around information disinformation. He's based in Lisbon. And you can see he's been working with data sets, typesets since about 2019. So you can look at his website.
Any questions for Brona? I would like to thank her for coloring our discussion at Descon 8.0 with all these wonderful examples of artists thinking from way back and how it's all very relevant because, as you said, we don't always think that we have the artists to tell us what to do next and how they're also minimizing data sets, but it's all hard to combine. So yes, if you have any questions, we will still be here, and we know we're between you and the lunch.
I almost do not dare to ask because it was a wonderful inspiration, and it doesn't have to have a purpose. It's just artistic, and yeah, you see that data sets can generate art, and one can embrace it. And but for example, it could have an impact on the aesthetics of user interface design or something with a purpose. But do you have an idea or let's say a thesis or some desire or requests to all those programmers here? What it should be?
Yeah, thank you for that question. And I think a lot of what we work on as artists is sort of symbolic meaning or intuitive meaning that somehow is like a pattern language. And I think that there is obviously lots of ways in which you could look at this. I mean, Daniel Brown, for example, is also a very successful designer. And there's a complete borderland between this work and design interaction as well. I emphasize the more symbolic, like poetical today, but there are other directions. I think with Rodolfo's work, it could be a follow-up workshop, perhaps. So.
Great idea, yeah.
It's less a question than a comment, or maybe a question for later, but I was wondering, connecting the two aspects of the previous talk and your talk of, we hear about, okay, there is open and fair data principles to make data less dark in order for, by them being reused, right? Is there, I'm pretty sure there is a lot of artists, but could you name some examples, or do you think of some artists, like the one we heard here, at parts use their own data sets, their own, the images of their parents, of what is in their own environment as a data set. But there is a lot of art that uses open data, public data from that data sets that we've heard before, to then make those visible or give also a bit of a broader aspect of how we could reuse them. We can't only reuse them for science, but with applications, with open data projects like Rimerco does, right? Like they have a website where you can see, where you can visualize air quality. And then the art, I think, is like the other end of the spectrum of like all of those possibilities of how to reuse those data. So could you name some examples, names? Do you have?
Yeah, I probably won't come up with a list for you now because I was focusing, but I do think in terms of my own thinking, that's very helpful, because the key thing in trying to join together, for example, what Hans Rockmeyer is doing and the open movement in concrete poetry, where people were reproducing, they all wanted to use a kind of there was a relational aesthetic emerging, so you could recognize the work of one person in Stuttgart and another in Sao Paulo. But at the same time, there was always a slight difference. So what I've been looking at is difference in its iteration, because that's sort of how it grew as a network of interrelation. Partly because if you sent a poem from one place to another, it would be designed and typeset in a different way, but it will still retain something of the original author. So it's a kind of intertextual shift that's taking place at that time. But on the other hand, and they're also starting to use Futura typeface a lot, which as almost like a format before formatting. And that's a universal shift, an intersemiotic shift that's happening. I think what we're now seeing is a slightly sort of amplification of the almost encrypting of it, not necessarily the underlying data, but the encrypting of the surface, so as to almost kind of add a level of privacy back, or authenticity, or authorship back into the use of code, because code is now quotidian. You know, we all have access to formats, and artists are always trying to work with what the next level is and the next layer. So, you know, there's obviously been so much work in the arts on open data. I'm kind of parking that for a moment. That's what the whole code conference was about, to try and look at something else, which is more about an otherness. So this, what I call my thesis, autopoetics. I'm sort of interested in it's not so much self-expression, but the expression of otherness, as in the autopoetic system. So that almost moves beyond the self of the artist into some other space, which could be a relationship with the machine, or with the code, or with the data, rather than necessarily trying to set up a collectivist approach with other artists.
Thank you so much, Brona. We'll be back here at 4, and there's light lunch downstairs for now, so hang around. See you. Of censoring, and we'll hear if that exists. So yeah, please, Jan, the floor is yours. Thank you.
Thank you so much. Hi everyone. My name is Jan Krasni, and I work at an interesting institution, which, I mean, in the course of my lecture, you will understand what I refer to when I talk about censoring. I work at the Institute for Research on Anti-Semitism, and there we deal with lots of material that may be maybe a little bit problematic. But let's jump into my talk, and let's start with some random, or maybe not so random, questions. I love technology. Okay, it died. Yay! Now it works. Fantastic, fantastic. So let's start with some random questions. What would you say, is historical truth important? Ah, very good, very good, very good, very good. What is historical truth? Well, if we, I don't know, let's say everything that is recorded in the archives, would you say it is important? Oh, right.
I'm sorry. Yes, Alexander from Germany. I think, yes, it is important to have untempered access, at least for researchers, to gain an understanding of the context of its original and to develop a new interpretation. Because if it's tempered, then you can't do original research.
Okay, so I will sum it up. Alexander thinks it is important to have historical truth, and it is important to have access to it. Very good. Then let's go to the next questions. What do you think, guys? What would happen if we would open all the archives? I believe this is one of the favorite questions of all conspiracy theorists. If we would make them completely accessible for everyone.
Happen if no, I wanted to ask, like,
Historical archives.
yeah, but what if we don't have an
Yeah, if the existing archives would
I
be
don't know. I'm more interested in non-archives.
okay.
What is missing in the archives? Like who?
Okay.
Like,
The archives
Alexander has the
Yeah, it's easy to foresee that if you, for example, provide a PURL, a persistent URL, for, let's say, a in Germany forbidden Nazi symbol, then it will be embedded in other hate speech sites.
we are approaching the problem of myself. Okay, and then of course I have to I couldn't not ask this question because it's all over the media. You don't have to answer it. I'm pretty sure that most of us here are against all the values that stand behind behind racism or anti-Semitism, Nazi ideology. But my next question is a little bit closer to that. So, do you think if we say we should open the archives, or if we should say historical truth is important, would it be okay that everyone would have access to Mein Kampf, to uncommented edition, or to all the scientific literature? Just think about eugenics. That was in place in Sweden until recently. Well, not until a few years ago, but until a few decades ago. If this kind of scientific literature would be accessible to everyone, and do you think it would make sense, or do you think it would make sense that various arguments and a lot of literature that is inside these archives and that questions the existence of atrocities in the Second World War or other atrocities would be publicly accessible in the online libraries, e-libraries, right? Now, this is part where your answer, which I agree with, that archives should be open and should be completely accessible, this is where it gets a little bit tricky. Yeah, I'm not sure that this makes sense, qualified researchers, because you know how easy it is to access any archive and to say I am a qualified researcher, and then you're in there, and you can get almost anything from any archive. So yeah, I believe it is a little bit more tricky than splitting people into qualified and unqualified. But
hiding those things, it's also like hiding your own history. in a way, like hiding the
Let's get
white
into it.
colonial.
Maybe my talk will answer to this question. Because I mean, yeah. Let's come to it. If I don't answer your question, then please don't forget. So most of the archives are partially publicly accessible. Yet they are storing dark secrets from the past. And the most important thing, especially when it comes to the archive of the organization of the institute where I work, they are hiding this problematic material. Problematic material that can be used, right? That can be instrumentalized, especially today when we have so much hate speech and hate discourses and promotion of hate ideology. I've been working in this field for, well, at least 6 years of hate discourses and hate ideology. So I know what I'm talking about. It really can be problematic, especially when people take pieces of facts from the past and then use it in order to promote their position. Right. So let's skip to another topic, and in a second we will combine both topics together. If you were trying to get a job in Germany in the academic field, you saw that there are many positions in the field of creation or promotion or working on research data infrastructures. And there are lots of grants, well, Bjorn was mentioning it today, by many research foundations and organizations that support research for so-called innovative and explorative approaches for e-research infrastructures. Now, the interesting thing is that it is not the case only in Germany. It is case in, well, basically all of EU, right? What people there are working on, and what Bjorn mentioned today, people are working on finding technical, educational, juridical, and organizational solutions for research data management and for research data infrastructures, right? Now, when we talk about the research infrastructure, what is it, right? So it is, as I wrote here, it is important for knowledge exchange all over on the international level, the level of EU, and it is anchored, it is very deeply rooted in the idea of open science. And open science means that, well, open science is super important for all of us for this event, because that free access to research data is what makes possible citizen science, right? It is what makes possible not to do many repeats of the same experiment, right? So it is super important. And we already mentioned several times fair management, that all the data that belong to this, that are stored in these infrastructures are findable, accessible, interoperable, and reusable. And interoperable, it's especially important because of this idea. It should be accessible for all the people within Europe. Research infrastructure, and this is something that I find especially important, is about a comprehensive process of enveloping, the digital enveloping of science, right? And now when we talk about archives, it means creation of all the infrastructure that makes possible a digital object to be findable as such. Let me expand a little bit on RDIs, research data infrastructure, right? So they are the preparatory step for the digitalization as such. Because if you don't have infrastructure, you will never be able to get funding for digitalization. And if you don't digitalize objects from your libraries, from your research, or whatever you're doing, there will be no so-called digital turn. There will be no digital revolution. That is something that Bjorn mentioned today as well. It has to be bottom-up process, right? Because any digitalization process and creation of this infrastructure has to be something that people from the field, from the specific scientific field are doing. They have to start with it, right? So this infrastructure, it cannot be unified for all the world. It has to fit interests of the research. And then these institutions are those that ensure supranational cooperation or cooperation between countries. As you see, NFTI that we mentioned so many times today is only part of this larger project of European Open Science Cloud, right? And this cloud, as you mentioned in this meme today, it's just someone else's computer, right? So it's basically data centers all over the Europe. I believe Serbia also belonged and had several projects that belong to this EOSC framework. Right. Coming back to Germany, I just want to give you an example that Bjorn already mentioned today. In all the scientific on all the scientific fields, you have consortia, or basically associations of various universities in various disciplines, where people try to digitalize their data to make them accessible for all the people within the community. For me, or for my project, I have at least 3 or even 4 consortia that are relevant for my research or for my institute, right? So one institute can fit to several consortia. Now let's come to my problem, right, or to my study, to my project, and to the idea how it is ethical to censor stuff, or how could be ethical to censor stuff. Let's put it like that. As I already mentioned, I work at the Center for Research on Anti-Semitism, and we have the largest library and archive of anti-Semitic material. So not only testimonies of the horrors of anti-Semitism, but also propaganda from various moments of history, right? From last 300 years, more or less, right? Then we also have a very I wanted to say nice, a very large archive of so-called anti-Semitic, of visual anti-Semitism, that is work of arts that promote anti-Semitism. And it's called Alava. If you want to Google it, you can, Alava project, and you can find something. And thanks to our researchers, we have constant influx of contemporary material where we come to research data. Basically, we have people who are collecting propaganda or pieces or digital objects connected to anti-Semitism. Right? Also, we have former researchers. Bjorn mentioned that today. He said, so dark data is what you have after a researcher dies, somewhere in a left drawer, a few USB sticks, right? So we have researchers who were working before USB sticks, and they gave us containers of documents and papers that we all have stored in our archive. We have also super funny things like radical right party programs. Right? So before AfD there was NPD. Before NPD there were some other movements, and we have all their manifestos and stuff like that. We have books and journals, fanzines, stuff like that. For historical pieces of anti-Semitism, we have. While I was digging in the archive, I stumbled upon a journal for questions of society. That's the translation of this journal from the 19th century that was basically explaining how it makes sense to create a ghetto. So it was from 19th century. So it is. We have a variety of material, right? Now, if you want to create a digital archive, if you want to have it digitalized, the logical question is, well, you work at a university. Every university has its own archive. Why don't you put your stuff in the university archive? Right? Well, no, because it's a special kind of archive. It's so-called toxic room. By not being able to put it in the university archive, you can't use the university infrastructure for that. It's not very likely that you will have an archivist that will spend his lifetime working on our archive, and because of its specifics, it's not possible to give this archive to someone else to curate it and to prepare it. Right? Many institutions have similar problems. So just for you not to think it is a problem of our institution. Any ethnographic museum in Germany, in Belgium, in France will have similar problem. They will have loads and loads of literature explaining how this or that nation is better than the slaves in Africa, explaining basically racial theory, giving arguments. And many of the institutions, and that is also part of research that we prepared before starting with this project proposal. Many of the institutions decline digitalizing such literature and decline putting it online when they stumble upon it. So in a way, you have some kind of structural whitewashing your past, because no one wants to put it online. No one wants to say this is also part of our history. So what do you need to do? Well, you need to make a system that obviously will help store digital objects, make possible semi-automatic annotation of all these digital objects, of all these magazines, works of art, whatever we have there, right? Generate archival records, basically, or so-called Findbücher, so-called finding aids, where you can see what is in specific documents. Because we are in a digital age, it would make innovative research approach possible. And finally, we come to censoring, right? Provide and or restrict access to this material. And then what we also have to do is to formulate ethical guidelines, because we don't have any. This is not something that people were working on until now. There is exactly one scientific article that deals with this problem so far, right? And when I talk about ethical guidelines, what I say is basically we need to find the middle path between Holocaust remembrance and anti-Semitism research and sharing hateful content, right? So on the one hand side, you should not whitewash your history, but on the other hand, you should not give arguments with the stamp of the true historical evidence that this is the right thing to do. Then you should meet the open science demands, definitely, because that is one of the greatest human achievements to make knowledge accessible, right? But also you should abide the law that prohibits dissemination of hateful material. Now, when it comes to training algorithms on this hateful material, you should try somehow to stop reproducing hateful content, but also you should stop omitting historical facts and data. Then one of the problems that I stumbled upon when I talked with my friends from IT they said, well, you shouldn't, and that was something very important for them, and maybe it is worth mentioning it. If a person will work with these materials, they said, well, you shouldn't put such pressure on anyone. No one should actually submerge in all this hateful content. So that is also one of the ethical problems. So what we need to do, and these are functional things, right, that correspond with the ethical problems, is making these diverse historical and contemporary materials searchable. That is the most important thing. In order to do that, you have to OCR it. HTR. HTR is handwriting text recognition, because there is a lot of historical material that is written by hand. Or, for example, I will give you an interesting example. We have memoirs of an SS officer, right? Or not his memoirs, but some of his writings that when he was preparing to give a talk. And I mean, we can read it, but it is not so easy to read. Right? If we would scan like thousands of such manuscripts, then it would we would really have to run HTR and not have someone who would right. Then other problem that we would have is omitting reproduction of hateful content, right? And that would depend on the status of inquiry, depending on what people want to find in that archive, right? And what kind of result for their query they would get. Right. So would then these existing principles, and that are basically ethical, right? They are value-based in the idea of open science. In how far would they be applicable to our archive of hate, of historical hate, and other archives? Now, for example, let's imagine that we have solved all the problems, right? That we have a solution for that. We have an ethical solution for that. How would we convince others of applying the same ethical solutions and abiding them? So in order to do that, we believe it would be important to create some kind of a living lab, right? A place like this here, where people from various disciplines would come together. So people who are building research infrastructures, people who are doing research, people from the civil society organizations, and who would make some solutions for all the ethical problems that I already mentioned. Right. So Luciano Floridi is one of the leading ethicists of the digital and promoters of so-called digital governance. So what he says is not only, there are like more or less 4 steps in finding these solutions. So it is not enough to critically question things and then to make fuss about it, right? Signaling the problems, but it is important to engage with the stakeholders, basically with all these people, right? And then to design and implement shareable and stable solutions. So in other words, building an infrastructure with this thought, with this ethical idea, would be probably the best way to deal with it, right? So one more time, I believe this is the last thing for you to imagine how dangerous such a project would be. You need to combine all these systemic solutions, right? You need to use transcription models. You need to use multimodal learning models in order to achieve full text search. So what it means is that there is a whole jungle of large language models that would be trained on this hateful material from, in our case, from three centuries. So you can imagine how problematic, even on this level, would it be to create an infrastructure and to put all the digital objects into it. So basically, that's all. Thank you very much. I have some visuals. So if you want to see what kind of material I was talking about, but so disclaimer, it's very it's terrible, right? It's just it's full of all kinds of stereotypes, anti-Semitic stereotypes. And if you decide to want to see it, then I would ask not to stream it, because it wouldn't be ethical. Thank you.
One question. Speaker waiting for us to start his presentation.
So you said you started there. How far did you get at your institution? It's just basic ideas and problematization and awareness? Okay.
No, we didn't start with the project itself. We are we should submit the proposal in a few weeks. That's these are the problems that we're dealing with. So the question is, which period does our archive cover? Well, more or less three centuries up to today. Yes, we have also current. We have research data from projects that ended a year ago or half a year ago. That's also part of it. So is it ethical to censor or not? It's not an answered question.
Not a straightforward question. Thank you so much. A big round of applause for Jan Krasni. And our next talk is coming from Germany. It's Dr. Sergio Genovesi, who's online, and he's an expert on, well, policy frameworks for artificial intelligence. And today he will give us a little bit of insight of how the regulation works, how it's structured, and make some connections to the environment as well, because Descon is about technology and ecology. So with that, it would be great to get Sergio online. I know you're online, but also to see him here and his slides. Let's test to see if we can see Sergio's presentation. We have it. Hello, Sergio. Really well. From wherever you are. Yes, so we have your presentation as well, and shall we, or would you be happy to run it yourself, just to agree on that? Yes, you're sharing now. We can see the side. Excellent. Yes, it does. So welcome again to Belgrade remotely, and the floor is yours, and we'll have some questions afterwards. Thank you.
concept. So you heard a lot about environmental and societal sustainability today. The economical is just another component that complements this image. And about these components being intertwined, just think about the societal consequences of the environmental crisis, or about the economical consequences of the societal disruption caused by AI system, for example, in the world of works and jobs. So when talking about AI sustainability, is necessary to focus on these three areas and to critically analyze the trade-off that may emerge. Because if we go all in environmental sustainability, we might oversee societal and economical issues and vice versa. So AI sustainability is a complex matter. And here are some points I brought to you about main concerns of AI and sustainability. I will go through this quickly, since also the previous speaker already addressed some of the points. So this list is not exhaustive, but you all know that AI has high energy consumption for training and operation. And we also use a misleading vocabulary where we think we talk about the cloud, but the cloud is someone else's computer, as we saw in a slide by a presenter before. And so this terminology is misleading. And cloud operation require high energy. The focus should not only be on hardware, but also on software, but also on hardware, because resource extraction for hardware construction is a big topic, which has economic and societal consequences, environmental and societal consequences. About the environment, this has rare material being extracted, and about the societal consequences, we can think about the working condition of those workers extracting and mining the materials. And together with extraction, also electronic waste is a big topic. And we all know that we have a problem with hardware disposal, and this problem is not getting less severe with the increase in production of hardware, also of AI system. So about society, we heard about algorithmic bias, so I won't talk about that longer. We know about severe privacy issues around data collection for AI system and their training, which are also related with risks of misuse of personal information. And I would like to stress once again the problem of working condition of digital laborers. I can warmly suggest the book Ghost Work about the condition of ghost workers. So those invisible digital laborer responsible for the training of the system we use. In the last year, we had out of scandals concerning training of LLMs, for example, 2 years ago, the one with the people in Kenya doing click work to train software by OpenAI to recognize violence and sexually explicit pictures. And these are all societal issues behind AI that are not visible, but that are there. And about the economy, we know about the high cost of implementation of AI, which can be prohibitive for smaller realities. We know about the disruptiveness of new business models, and being disruptive is not always bad, but sometimes it is. So it causes economic instability and job losses, and we all know about the concentration of economic power. But I didn't want to make you all said today, so I brought another slide with opportunities in the field of AI and sustainability, because there are two faces of the coin. We know AI has big sustainability issues, but can also help address sustainability issues. For example, about energy consumption, a trivial example I like to make is if the system helps saving more energy that it consumes, then in the end it has a positive impact when it comes to environmental sustainability. The problem is not all system helps saving more energy than they use. And they also have very interesting application in the monitoring of natural resources, in optimizing waste sorting, and in the research of AI and sustainability, the concept of AI for SDGs, social development goals, it is a thing, it's a spread concept. So AI is used for a variety of applications in healthcare, education, environmental application, and so on. And actually, we know about all these horrible stories about biased algorithms, but if algorithms were unbiased and good functioning, they could actually support a fair allocation of services and resources and support social welfare. So the real goal would be to get rid of the sustainability challenges in order to let AI flourish in the sustainability field, and also about the economics application. It can enhance productivity, fight financial crimes, improve logistics. But again, like in the environmental application, not always using AI has an added value. So we know that due to the AI hype, everybody wants to sell AI application, but there are cases and people offering, let's say, a good consulting services in this field could say, in this case, you don't need AI. So it's a good informed choice also to say here, using AI has no added value. The economic, it's not economic sustainable, use the traditional method. So like the motto, don't AI everything. And I brought with me a little overview of the regulation and standardization activity around AI and sustainability. So starting from the less binding ones, standards and guidelines, which may be binding if they are in a legal and regulative framework. So sustainability is addressed in a very high number of guidelines. Whenever you talk about responsible AI, trustworthy AI, then the keyword sustainability is dropped at least, and this mention is also in very important documents by IEEE, OECD, high-level expert group of the European Union, by UNESCO, not last the ethical impact assessment by UNESCO of the last year, and so on. There is one important standard in the drafting and negotiation phase by ISO IEC. The standard is environmental sustainability aspects of AI systems. The fact is, today, none of these documents is legally binding. So it's all gray literature that goes in the, let's say, in the area of digital corporate responsibility. Corporation might follow them, might not. Right now, it's not mandatory to follow this. And then we have the EU AI Act, and the EU AI Act, which is legally binding in the EU, and for those making business with the EU, This is, of course, very legally binding, and penalties are very, very, very high for non-compliance. However, sustainability is addressed only indirectly, meaning that, of course, is a big component of data governance. So, for example, addressing social sustainability issues, there are privacy issues, data origin issues. The AI Act wants to avoid click work, ghost work, worker exploitation as well. So there are some requirements concerning data origin. There are requirements concerning system efficiency, also energetic efficiency, even though they stay a little bit back. And of course, the most important things is that there is also a human right impact assessment to be done for high-risk system. And since sustainability have a direct impact on human rights, sustainability consideration can flow in this human right impact assessment. But even here, as we saw, it's not a very big topic. It's not the first keyword. And then there is a Supply Chain Act, which is also in the negotiation phase in Europe. Actually, last year, we were all afraid that politicians would stop the Supply Chain Act in Europe, and actually it was because of the Liberal Party in Germany that wanted to stop it at the European level. Then they came to an agreement. So now they're talking again about the Supply Chain Act and the European level, but I don't see it coming this year, maybe next year, we will see. The thing is, in Germany, there is already a Supply Chain Act. I think it's the first one in the world to have this extent, but it affects only company with at least 1,000 employees in Germany. So I didn't make the count of the big tech company with at least 1,000 employees in Germany, but maybe some of the big tech is affected by the Supply Chain Act, and this is a big deal. This is a big deal because the core elements of the due diligence obligation include establishing a risk management system to prevent risk of human rights violation and damage to the environment. But also here we have at least one problem, maybe two or three. The problem is that this is also very vague, and it is difficult to check for non-compliance, and also difficult to demonstrate compliance. So the application and the implementation are very hard. This is also a piece of regulation that wasn't thought for AI or for digital services initially. I think the first industry that comes into mind is the clothing industry or other kind of industries. But of course, it has consequences also for the AI industry, and we will see how big tech will be impacted by this act, especially if the EU will establish its own supply chain act. And I mean, I don't want to be Eurocentric, maybe also other legal frameworks will implement this kind of regulation. To my knowledge, and please tell me if I'm wrong, but to my knowledge, Germany was the first country having this kind of regulation, setting these strict rules on preventing human rights violation and damage to the environment along the whole supply chain. And I talked about a gold rush towards sustainability tools and certification. So here I brought some examples with me. I have to say the two examples concerning sustainability tools come from Germany. Again, I am based here, and I know that here a lot of money is being invested in developing such tools. So one tool comes from Algorithm Watch and the project Sustain. They developed a sustainability index for artificial intelligence. Here, I also have an illustration, unfortunately in German, but I know they published a paper in 2024 with all these criteria, also in English. And as you can see, we have social, ecological, and economic criteria. So what they did is to produce a very detailed list of sustainability indicators that you can use when assessing the sustainability of your tool or service, and use it as a kind of checklist or as an assessment tool, which I find very good and very impressive. And here on the bottom of the screen, on the left, this is another interesting tool that was developed by a team of German scientists. I mean, I don't know if all of them were German, but it was a German project. And it was a care label certification for AI systems. And I find the graphic representation is very nice, because the idea of this research team was to produce a care label certification like the one we have for our dishwasher or our washing machine. So with this label A to D, and so we can rate how good or how bad the model performs in different sustainability area. This group was focused on energy consumption. And here on the bottom, in the right, we see, if you Google sustainability tools for AI, then you find a lot of tools, existing tools. These are add-ons, expansion that you can use to track your CO2 emissions or your energy consumption deriving from your AI model. And I think, I don't know how effective it is, because I have to confess, I did not try it myself. I'm also not a programmer or a developer, but I find impressive that we have this large amount of tools. So coming to minimum datasets, here again, I wanted to list challenges and opportunities. And this time I start with the opportunities, because I want to be an optimist, and minimum datasets are actually promising, because of course, having smaller datasets, we need less computational power to train and operate, resulting in energy saving and lower carbon emissions. People responsible for putting together the datasets must focus on data quality in order to avoid having totally random results. So the motto would be here, quality instead of quantity. And the hope, we hope here to be able to reduce algorithmic bias using high quality, reliable data. Of course, there is the challenge related to this, which I will spoil right now, is that the open question, if it is possible to sacrifice a part of the data, or to sacrifice part of the data, if we can still have representativeness and diversity in the data set, reducing it to a minimum. But it in any case, a promising thing. And the good news is that user privacy and data protection will be preserved. I mean, the principle of data reducivity and reduction, data scarcity, it's also in GDPR, because as a principle, we need to avoid processing unnecessary data. We just need the necessary data. So this will, in any case, comply with this GDPR principle and take it to the next level, avoiding privacy breach. So I already mentioned one challenge, the complexity of data selection. The other two challenges I brought with me, and again, these two lists are not exhaustive. While focusing on data quality, we might avoid overfitting. Having few data might lead to underfitting, so that there is potential for poor model performance. And of course, we have also a problem with scalability, because using targeted data in a smaller data set could face difficulties in scaling to larger or more complex data environments. So, to conclude, we saw the opportunities and challenges of AI technology. We saw that using minimum datasets is promising and could improve energy and cost efficiency, enhance data quality, and protect user privacy. And we saw that effective regulation is necessary and crucial to guide the development of sustainable AI practice, but we also know that right now there is much work to do on the regulatory side. So, in my view, the next step toward sustainability, also supported by minimum datasets, is one of the key tasks is doing research to see how minimum datasets can address sustainability issues. A multi-stakeholder collaboration on the development on standard and regulation addressing AI sustainability issues, because right now we are not doing good on this side. We still need good regulations and good standards addressing sustainability issues, and spread stronger ethical standards concerning data origin, collection, and processing, because while the way to produce new regulation is a longer way, we can immediately spread ethical standards in the community, pitch these high ethical standards, and informed and aware developer can start today working with these higher ethical standards. And that will be it. Thank you very much, and I'm happy about the Q&A.
Thank you so much, Sergio, for this elaborate thinking about how to combine the minimum data sets. We do have a panel after the next speaker that will go further down into the details. What is the concept, and what is a minimum data set? So does anyone have any question for Sergio, perhaps? Yes, there's one.
That was really thorough and comprehensive. I suppose the only thing that I feel like asking is, how do you feel, or what do you think are the challenges in terms of public perception of these issues, and how might those be addressed within this comprehensive policy scenario?
So public perception is crucial because it is steering what politics is doing ultimately. So if the public shows they want change now in the field of sustainability, then politics will try to address this. And what you can do as informed people, as developer, as researcher, is to share your knowledge and share your findings with the public. As I said, I came from the research field, and that it was a very active, vibrant community talking about this topic. I have to say, now I am outside the bubble, and I see that this discussion has not a big resonance as I thought it was having while I was in the researcher filter bubble. So the thing is, it's good to go outside the ivory tower. It's good to go outside the filter bubble and try to spread the news as much as we can, because indeed not that many people are informed as we think.
Thank you again. I believe there's no further questions now. So we thank you, and we'll continue with the next speaker, and that is
Thank you,
Goran Milovanović. So Sergio, thanks again for joining us. It's been a pleasure to have you here, and we'll be in touch for a later panel. We'll get the technical team to put the next presentation on. There we go. Success.
Technical team putting the next presentation on. So.
Hello, Goran.
Hello. Oh.
We have Goran dialing in. He's he's a researcher and a data scientist, and he is familiar to some of you because he does live in Belgrade, but today he's not here. So he's, I don't know where you are, into which part of the world, but welcome.
Thank you very much. Krakow, actually, Poland. So I really planned to be in Belgrade, but planning nowadays is thoroughly, I don't know, disrupted activity, I would say. So unfortunately, I couldn't join you live in Belgrade. I apologize for that, but at least we will have this presentation. I guess an interesting discussion, hopefully an inspiring discussion of this thing. So I titled it, Uncertainty in Our Digital Lives, because I really think it's a topic that addresses us as human beings in the first place, except for the talk will be technologically focused. But then, we are the users of technology, and that is always about us, right? And especially when it comes to this new fancy things, generative AIs, large language models, I will be focusing on that in my talk. Only a few words about me. I'm currently a chief AI officer for SmartTalk, that's a Serbian-Dutch startup. We work in media technologies. We work with newsroom. We process tons of text, build recommendation systems for them, do data analysis, do machine learning for them, and similar things. In the media industry. And my background is, it was already noticed, I'm a data scientist. I have a PhD in cognitive sciences, psychology, and actually spent most of my life, I'm 50 now, most of the previous 30 years doing things like statistical learning, figuring out how to hack, how to reverse engineer the human brain and the human mind from experimental data. So pretty much that kind of life. And today, what's going to be the story about the following concepts, I will say. We need to say something about order, disorder, and predictability. Believe it or not, very crucial things for our lives in general, as I will try to show you. Then I want to relate those concepts with the concept of information entropy, right? And I will try to easily, as much as possible, in a simple way, explain what information entropy is for people with non-technical background, people who are not in STEM and who didn't learn information theory, because that entropy thing, that's, more often than not, it's like that teenage sex type of content, if you allow me to express myself in that way. So it's really talked about, but not many people really get it, what it is. And on the other hand, I will show you that it's really something very easy and a concept with a very wide application in your understanding of the world, not only of technology, data, and similar texts. And then I want to relate these concepts and the whole previous exposition to something which I believe could become a very serious problem when it comes to the data sets used to train these contemporary monsters like ChatGPT, like Anthropic Claude, Google Gemini, or Mistral's models, these large machines that can mimic human language and human intelligence up to a degree, because I don't know how disappointed you will be when I tell you that, but we simply only call these systems AI, but they're really light years away from being anything similar to natural human intelligence, but they're still very, very, very useful, and there is a reason why we started calling them AI systems now. In a way, they really do mimic some intelligent processes. Okay, so look, I have a question for you to begin with. So, did you ever ask yourself how chaos and disorder are measured? Or did you ever at all assume that something which is disordered or found in a state of chaos can be measured? So, let's take a look, for example, at this product of an AI system. By the way, I created this using the Midjourney generative AI system. It produces visual representations from text, from songs, right? So when you look at these 4 images, looks like abstract painting, like perhaps Jackson Pollock in black and white, this stuff, right? Whatever. We can see a mixture of regularity and irregularity. So it's not like a complete chaos. We can find some recognizable elements, even some symmetry somewhere, etc. But if we would ask ourselves, look, I mean, which of these things is more chaotic, right? So is there a way to measure that? Is it possible to measure the, order and disorder in any system in a way similarly as we measure length and time in physics or sciences in general, in practical life, right? So look, well, it is possible, but before we proceed towards that concept, the concept of information, entropy information at all, and relate it to the contemporary generative AIs and the data sets that we use to train them, we need a smallish technical introduction. Look, so I'm an analyst, right? And typically, I analyze user behavior, and let's assume that I want to analyze user behavior on some social network, right? Okay. So I want to learn as much as I can about some user, right? By looking at when does that user clicks or reacts in some way on a social media post, okay? So I have 5 users here. Look, so user A, B, C, D, and E. And let's take a look at the first one. By 1, I will mark an event when a person liked something, so reacted something on a social media, right? Be it Instagram, TikTok, Facebook, whatever, right? So look at the first guy, the A person, they always click. Whatever we show them on social media, they always click, right? So once, okay. That one is easy, right? So look at the last one, the E user, it's all zeros, right? So that guy is simply looking at the social media, he never clicks on anything. Take a look at the user B, who is more often reacting than not, and at the user E, who is more often not reacting than reacting, right? Seldom he has once, which means he clicked, he did something, right? Most of the time, zeros, right? Well, it's not full zeros like E, but D is really only seldom, reacting only seldom, right? Now take a look at the user C, and approximately we will find 50% of time that person is reacting on something, and 50% of time that they're doing nothing. Okay. Now, a question that I would like you to ask yourselves is, who of these users, who of them are more predictable in their behavior and who are less predictable or unpredictable in their behavior? As an analyst, where will I face problems? But look, I mean, user A and user E are fully predictable. Like I can be almost certain from these samples that I'm looking at that if user A, if I show something to them on a social network, they will react, right? User E, I can be pretty certain that they will not react, right? Now, my odds in the prediction game are not bad for B and D because B reacts most of the time. So if I would have to make a bet, I would probably put my money on the prediction that user B will react on the next team that they see, as well as that user D will not. Okay, they will do nothing, most probably. User C is almost 50-50. They react half of the time. Can I predict the next step of user C? If I show them some social media posts, will those people click or will those people not click? Okay. Now, it's a very, very important intuition that we need to build here and to start understanding something. So look, ordered systems are predictable, right? Ordered systems. When you take a look at the user A and E, there is a simple rule describing them. They're ordered systems, right? The rule for system A, for user A, like, okay, so they always click. And there is a simple rule for E, like they never click, okay? For B, we can say they click with 85, 90% of probability. For D, we can say they click with 10 or 15% of probability. But user C is problematic, right? Because that's a disordered system and he's not really predictable. There is no rule, you know. It's like tossing a fair coin. 50% of times you get heads, 50% of time you get tails. And it's really difficult to bet on a fair coin, right? Now, look, describing order and information has to do with probability, right? So I was already using terms like, you know, most of the time this system behaves in that way, or most of the time that system behaves in another way. So now let's think about a game, a system, a user on social media, once again, who have actually three actions at their disposal. We can call this action, say, B and C. Okay, so A can perhaps be there is a new social media post, do nothing. B can be there is a new social media post, like it. C can be engage, you know, share, comment on the post, something else, right? And if we observe any system which can take a number of different discrete states, or back to my example, a user who can do three different things, right? Then, by observing their behavior for some time, we can assign probabilities. We can count how many times they do what, A, B, or C, and we can calculate what's the probability that that user will A, do nothing, C, engage, or B, simply like something, okay? So we can assign particular numbers. So we are measuring that probability, counting, okay? And one thing, important thing to remember about probabilities, they always sum up to 1. Right? Okay, so we don't know if it's going to be A, which I assigned 0.45 or 45%. Is it going to be C with 0.28 probability, or is going to be B with 0.27? But what I know is that these three possibilities are exclusive. 2 of them cannot happen at the same time. 3 of them cannot happen at the same time. Only 1 can happen, so they are exclusive. And I know that I can add up exclusive probabilities of exclusive events to be precise, right? And they always need to sum up to 1. Now, that is interesting, but I really don't want to measure probability in order to describe the order or disorder in a system. I want to measure something else, which is called information, right? And in order to explain to you how entropy actually measures information, order, and disorder, right, I need to remind you of this following very simple psychological fact, and that is that we are surprised by low probable events, right? So low probable events in world at all, everything that surrounds us, those events are those that actually bring new information to us, right? Yeah. So if I buy a lottery ticket, which has an extremely low probability of bringing me, you know, some significant amount of money. So look, if I win the lottery, my numbers come out tomorrow or this evening, right? So I will be very, very, very surprised. And the amount of information that numbers carry are huge for me, right? Okay. But if I buy a lottery ticket every week, and of course I don't get any money because my numbers don't go out. Why? Because it's a very, very minor probability that you can actually win a lottery, right? You will not be surprised, right? That's just the world as usual, as it is. You can say, okay, somebody's really, really lucky, but not me. There's 8 billion people on the earth, right? So picking who will win something by pure chance is very, very difficult, right? So let's talk about describing that simple psychological intuition that we are actually surprised by low probable events. Now, this is bad already, right? It's not really. This is high school mathematics, and you actually, I mean, it's very, very difficult that it has a low probability you haven't seen this thing in your high school education. Something simple, which is called a logarithmic function, okay? They can have these different bases, so-called. It can be logarithm with the base of 2, the natural one, which has actually a base of 2.71, the logarithm 10. In information theory, in entropy, in computer science, we typically use this logarithm with the base of 2, but all the conclusions will nevertheless be the same. You can use any of them. What I'm interested here is, I'm interested in the properties of this nice function, and only one part of this function. Look, you can see to the left, the x-axis spans from 0 to 1, the very beginning, and here below that, the logarithm function is negative. And since I want to use logarithm to talk about probabilities and describe what surprise and information are, I'm really interested in this part because probabilities can fall only between 0 and 1, right? Okay, so look, let's zoom in. Let's zoom in. And now, look, between 0 and 1, I want to place a probability of something happening, right? Now, look, a logarithmic function has a very nice property on that domain on that range between 0 and 1. Look, if something has a probability of 0, right, logarithm of 0 is actually going to be minus infinity. You can see how sharply the logarithmic function is actually decaying. It drops sharply as you get closer to 0, right? So that is a nice property. And another nice property is something has a probability of 1. A logarithm always has the value of 0. Now, what has a probability of 1? Certain events have a probability of 1. And if something is certain, a certain event, something is completely predictable, I don't want to be surprised by it, okay? But if the impossible happens, which is not possible, right? But if impossible happens, something which has a probability of 0, and that happens, right? I want to be infinitely surprised, right? Because the impossible happened, okay? And the only way to describe my surprise by impossibility is, I'm infinitely surprised. The only thing that I don't like here is this is the negative part of the function, so I have this minus signs here, and that is not really intuitive. And then there is an easy thing you want to do. You put minus in front of the logarithm function, and you simply turn it around, you flip it around, right? Don't worry, I'll have a nicer drawing than this, right? So surprise is something that we say in mathematics is the negative logarithm of probability. So minus log of probability measures surprise. Once again, just to make sure that we are on the same page here, look, why is that so? All probabilities go from 0 to 1. 0 is not a possible event. That cannot happen. 1 is a certain event. You don't even have to predict it. 1 is the sun will rise tomorrow, let's say, okay? So if you put minus logarithm of probability here, there is a very nice property because this thing now becomes a description of how much information are you getting from any event. Because when you go with the probability close to 0, it will measure infinity. The impossible thing would be infinitely surprising to us, right? When you go closer to 1, and if you hit 1, that's a certain event, and the surprise or the amount of information for a certain event is 0. Okay, and then everything else falls in between with the property that as faster we approach 0, the amount of information is higher and higher, perfectly matching our psychological intuition that things with low probability carry a lot of information for us, right? They surprise. Very good. Now, I don't know what is the, who in the audience has a technical background or not, but, entropy once for all, because it's really simple. Look, if we understand what surprise and information are, now let's take a look at the whole system, a user that can do 3 things, and he can do A1, A2, or A3 with different probabilities. And here, what do? We just need to know these probabilities. We can measure them by observing their behavior, for example. Then we compute minus logarithm of the first one, the second one, the third one, and we observe 3 surprise measures, okay? Entropy, the information entropy, is nothing else but the average of these 3 numbers. You just sum up these 3 numbers together and divide them by 3, and that is entropy. And entropy is the average information, but it talks about the system as a whole, right? It talks about the system as a whole. Surprise. I'm surprised if a user does something highly improbable, but surprise measures the information of one state of the system, of exactly what he did, right? Entropy, as the average surprise, measures how uncertain is the system as a whole, how unpredictable is that user that I'm looking at. Look now, there is one very important property about entropy that we need to understand here. So look, this is some system A, and I have here a system B and system C. System C, the one which has 3 equally probable states. So all probabilities are 0.33333, 0.333, 0.333, okay? So can I predict the behavior of system C? Very difficult, probably not, right? Okay. System C has the maximum possible entropy. when everything is equiprobable, that system is the most uncertain system above all, beyond all these three. Sorry, among these three systems, okay? So that one is unpredictable. If we would compute the entropy for the system C, that would be the maximum of these three numbers here. If we compute the entropy of system A and system B is obviously one with the minimal entropy. Why? It has one event, the first event, which is very highly probable, two states that are not highly probable. So this one is really predictable. System A is a bit more predictable than system C, but it's less predictable than B. It is easier for B to say what will happen, right? In A, well, yeah, one of the things is more probable than the second one more probable than the third one. So it is predictable in a way, but B is the one that we can easily predict, right? And never forget that. So entropy is technically, it's a very simple concept. It relies on high school mathematics, right? But it describes the whole system. Here's the famous equation. So the next time you see this and you think, oh, that information theory and entropy, that's rocket science. It's absolutely not rocket science. It's high school mathematics. The whole expression of information entropy here, it is just a compact way in mathematics to compute the average of three surprises, as I can just show you. Nothing else. I just like to have it. It's a famous equation, after all. Okay, now, how does this relate to the story about generative AI and large language models and the data sets that we use to train them? Look, these large language models that are so popular nowadays, like ChatGPT or Anthropic Claude or whatever you choose to use, they do only one thing, and only one thing exists in that operation. Given your prompt, so whatever you enter to a system, the system has only one task, and that is it will attempt to predict the next word. What is a good continuation of what you have entered as an input, right? So if you ask yourself, how do they respond by whole sentences and paragraphs? You send the prompt runs through a whole machine learning, a whole very huge machine learning model called the neural network, and the neural network spits out one word, one single word, even technically speaking, a piece of a word, which is called the token, but that is not important now. It gives you one word. What happens next is the system takes your prompt, adds the word that it predicted, puts it here, runs again to obtain the second word, and then the third, and then the fourth, and the fifth, etc., until you receive the full answer from the system. So that's the only thing happening here. Whoever thinks that this system somehow have a structure, understand the grammar of the sentences or anything similar to it, no, they don't. They just predict one single next word from a given prompt, and then they iterate until they produce whole sentences, right? So how does it actually work? Well, in a complicated way that I will not enter here, but look, so on the output side of these huge neural networks, right, there is something which is called the vocabulary. I will provide an illustration, don't worry. So you have a very huge machine learning model, okay, very huge, very complicated. You enter prompts here, right? The output layer, as we call it, the output layer is the vocabulary. It contains all possible words that can be produced at all. Right? And the task of the system is just to match your prompt and to analyze it so well that when the signals that travel through the system hit that vocabulary here, okay, so they will activate all words in the vocabulary. The goal of the system is to activate the correct word, the one that will naturally continue the sentence, right? So that is actually all that happens, right? So information run through the system, okay, in the end it hits the vocabulary, and it needs to activate something in the output layer. This is a very simplified representation. We have an output layer here with only two words, let's say, right? But in reality, it's the size of vocabulary. So you have, well, because we use tokens and not words, we have tens of thousands of output layer things in an output layer. But if we would use words, we would have millions, right? And that's everything that happens. Your prompt here it is coded into numbers. It runs to the model selects. It activates all the vocabulary. You need to find a word which has the highest probability of continuing the whole thing, right? So look, if we enter beautifully paired the model A has this activation of the vocabulary, model B has this activation of the vocabulary, and model C has this activation of the vocabulary. Once again, I mean, really all the words that the model knows about will be active, okay? We are just looking here at probably, let's say, the most active words. So which model is the better? Which one is the best, sorry? Well, it must be model B, which is at the same time one with a minimal entropy. Why? Because this model activated the word cat, beautifully per the cat, right? Activated the word cat way more than dog or whale. Okay, so model A would get the correct response because cat has the maximum activation, right? But look, dog and whale are competing, and here dog and whale in model B are not really competing with the cat. So model B is still better. It has a more certain response, right? Look at the model C, it has a maximum entropy. This is not a good large language model, right? This one is confused. It says with equal probability, this sentence could be completed by adding cat, dog, or a whale, right? So we would like to go to model A, which means something very important to us in this conversation. The entropy of this vocabulary activation is crucial, right? And also don't forget that we use human-generated data to train these models, right? And when I say human-generated data, we really use, you can really, I mean, you wouldn't be mistaken to think of the training sets for ChatGPT, Anthropic Claude, Google Gemini, and all these similar things as of the complete history of the digital text available at all. That is what we are using to train. Like everything that we as a humanity have produced as digital text enters their training, unless we are talking about something so private that it could never enter the data sets, right? Okay, so look now what happens. Let's now talk about the usage of these models and what do we do with them. What is nice about large language models is that here to the right, we have a system capable of producing synthetic text, the outputs of the model, right? And because of that, because the system was trained with almost a complete history of the digital text, and it can mimic human language very nicely, right? So to the left, we have the user of the generative AI system that is now able to use all this knowledge, right? All this knowledge here. But there is a bad thing about it, and that is, so when we all start using generative AI systems, and most of the people I know use generative AI systems, right? What is going to happen is that at some point, we will begin to train more and more powerful system with a mixture of human data and generative AI syntactic data. Why? Because we will be using the products of generative AI. Those products will end up online. They will be scraped and they will enter the data set, right? And someone wants to train a better, more capable new version model updated, they will start reusing the data that were generated by the model itself. What happens in such situations? Well, we know this even before, we knew this even before 2024, but the thing is just two most recent studies, right? We find that a self-consuming training loop produces correct outputs. However, the output declines in diversity depending on the proportion of the used generated data. Fresh data can slow down this decline, but not stop it. Given these concerning results, we encourage researchers to study methods to negate this process. In other words, and here is a study just recently published by Oxford scientists in, I think, Nature or Science, Nature probably, who also established the same result. If you start training new generations of large language models, and this also holds for the model that produce visual outputs like Midjourney or similar. If you start training new generative AI models, but if you start training them on the data that they generated themselves in several generations of models, the models decline. Okay, they start producing rubbish, or they end up in a state where they always give one and a single prediction for whatever you enter. That is something which is technically called the model collapse, right? And that is, of course, that by entropy. That's the link with that concept. Why? Because look, I mean, if you train things on self-generated data, right, you're actually isolating the system. In this case, you're isolating a large language model from any sources of fresh information. Nothing new enters the system, right? Okay, and the system, however smart it is, it can only produce, as you can write only in one style, and that is yours, right? So the system can only produce the data from the structure of the system itself. It cannot really produce something new. It cannot self-disrupt itself, right? So that is very similar to entropy in thermodynamics, if you like. If you remember the high school physics, right? The second law of thermodynamics, which says any isolated system, okay, will spontaneously tend to maximum entropy, right? That's a so-called thermodynamic death. Something similar happens here, right? Now, here is the problem in relation to the whole concept and the context of this nice conference that we're having. So look, I mean, the problem is that we desperately need more data. We don't have them. And we are now facing this problem with possibly using synthetic data. And that can be, I think, very dangerous, as I showed you. So we are already using almost everything that there is to train these things, almost everything. OpenAI is running around all news agencies, publishing houses, and media in this world, trying to cut the contracts and provide more compute for them, okay? Allow them to use their systems in advanced ways with more tokens, less limits, etc., in exchange for their news production in order to be able to obtain fresh data. That's a recent trend. It started happening this year. They already have contracts with several very, very large publishers, right? But that's not going to help because that is not enough. I mean, it's not enough. Even if we start writing data sets, training data specifically for them is not going to be enough, okay? So there is another thing. One could say, well, you know what? I mean, we can always intentionally prevent training new large language models by synthetic data, but there is a small paradox related to that. So, you know, I mean, we are constantly producing better and better models. And what else is a better large language model than the previous one, if not the one for which you cannot say whether its products are synthetic or human written, right? So a better model will be the one for which no other model can make a decision saying this is written by an AI or this is written by a human. After all, that is what we want, right? We want to hit artificial intelligence, right? So don't worry, because with these types of systems that we use now, we are definitely not going to discover AI in them, right? They are purely associative machinery. They're not symbolic machinery. It will not really work. But again, they mimic human language in a very, very nice way. So it will be increasingly difficult for all of us to manage the ecology of this data set. It will be increasingly difficult to say what is synthetic data, what is human-generated data. But if we let synthetic data back into the training of new and updated versions of the models, they will decay. We will observe an AI decadency, right? And that is the question with which I actually wanted to conclude my speech. I try to describe a problem which comes from my community of AI people, machine learning researchers, people who build these things and use them in our work every day. I'm not really sure that even I have the answer to this question, what to do about this problem, right? Of amassing this synthetic garbage that will enter the data sets. One could possibly say, well, you know, that's just a theoretical possibility, and God knows how much time will be needed for models to decay, right? And then we will figure out something before that happens. And the only response that I have for them is, you know, in 19th century, we started the Industrial Revolution, right? And pollution up to the level of climate changes, of global climate changes, was just a theoretical possibility, right? And look, where are we now, okay? So that is it, my dilemma, and I hope it was interesting to show you and relate all these concepts, but I have no answer to anything to conclude here. Just this open question that I would like to discuss with you. Thank you.
you so much. Goran will take a few questions. I'm sure you have inspired us to think deeper about these things, but there's one.
Yeah, I really enjoyed that. When I was looking at some of this last year, was reading about how AI systems were becoming more boring, and you can see it in terms of repetition already. And by this year, it's clear, as I was showing earlier, that a number of artists who are tuned to some of these things are creating their own data sets and sort of mystifying, as Robbie Barrett goes. The learning system, I think, is a form of strategic or tactical intervention, which fits really closely with the minimum sustainable data set, but in a very aesthetic, encoded sort of way. When you're talking about we, I think there are different we's in this particular environment in ecology, and the we of those who perhaps just don't want to roll over and die with the acceleration of AI and its hyperbolic rhetoric last year. I think the situations and the landscape's getting much more interesting. And funnily enough, Max Benzer, who I was talking about earlier, he used to write a lot about entropy and negentropy. I don't know whether that's something that you've looked at, but I'd be really interested in your take on that, because to some extent, Benzer thought that the negentropic was art because it could sustain itself.
Very, very similar. I mean, negative entropy is just an abbreviation for it's a negative entropy, because entropy, when you formulate it as a concept, it has a property that some people don't find it quite intuitive. You know, high entropy does not mean more order, right? High entropy means disorder, right? Okay. So if you want to measure the structure, if you want to measure the amount of order in a system, okay, you need negative entropy. You can put the minus sign in front, right? The same flip as I did with the logarithmic function. It's just a matter of how we describe things, right? Yes, culture, art, science, civilization, they're all in a sense negentropic. Yeah, they're all in a sense negentropic. We bring order to the world, right? And the point I would say of my talk in relation to these questions was that, you know, even the most rational of all of our constructions, like technology and especially computer things, information technology, still, as I hope to demonstrate, still can lead into situations we are really highly irrational for us, right? Because if we ruin the data and the whole AI ecosystem that we are trying to build now by this pollution with synthetic data, right, it will be hardly possible for us even to reconstruct that whole thing, to reset the whole situation at some point, right? And once again, for all those who think that it is just a theoretical possibility, I agree, it is a theoretical possibility. God knows when it will happen, if it happens, right? Maybe people come up with something new, right? But then again, we hope for that the industrial revolution will not do anything bad. And once again, look where are we now with the climate changes, right? Okay, so things are running faster nowadays. Events are faster due to this huge information exchange between us and the world globally. It took 200 years for the industrial civilization and the steam engine and the thermodynamical engine to change something globally on the planet in a bad way, right? Who does not guarantee you that this entropic death in the information arena will not happen in the next 50 years, right? So it's not highly probable that I will be around in 50 years, okay, but my children and our children will be there, right? So it's now the time to discuss about these things, I would say.
Thank you for that reply, and you made us all maybe a little bit smarter as to what we should do online. I never look at it the same way, how we react. I just ask everyone to give a huge round of applause for Goran. And
thank you all. And once again, really sorry that I'm not in Belgrade, but I just couldn't make it. Next
time. And please feel free to join us very soon for our panel as well on Datasets, if should you have time, but we also understand if you have to miss it. So we'll see it on YouTube later. Thanks. So we'll take a 1 minute break and set up, 2 minutes and set up the stage for the panel.
Da li radimo.
So idemo jedan. Može. Back to our panel on datasets. This afternoon we will explore some concept of this minimal sustainable datasets. You can see sustainable is in the brackets. We have not arrived yet to that conclusion. The panel that we have today will probably talk from their angle something, but I wanted to maybe just say what I had in mind, and then I'll let them discuss. And to me, the minimum data set is something that tells me, that I should collect very little for what I need to do. So I see it as a principle of, collection of data. And that begs the further question if these minimum data sets, whatever they are, can then be used, this minimum form, to feed into the large language models, which also need input to be trained, as we just heard earlier from Goran. So they should keep that essence in themselves. They should also, do useful things like not over-collect, so continue to share our privacy, but it should also improve the essence and functionality of the system because they have this essence, and that begs another question: would this data or minimum data sets ever be free from bias? Because if you compress them so long, do you lose the diversity? So this is like the conundrum that we will be thinking about today and tomorrow. And tomorrow we have a workshop, minimum data set manifesto. It may come with some guidelines that Sergio had earlier on that he mentioned about, for example, artificial intelligence and the sustainability. He made a few connections. So that is really what we're going to discuss. And if these small data sets are free from bias, is it an issue of scale or something else? Or what are the related or ecological, ethical issues that interplay with this concept? So without further ado, I'll pass the mic to our moderator, Bronac Ferran, and our speakers probably don't need introduction because you know them, but you might decide, you know them, and I'll do that as well. So we have Christo Bušek, who you'll hear tomorrow morning. He's a keynote speaker, and he's a journalist, an investigative journalist, and also data analyst and scientist. And we have also Professor Vladan Joller, who talked to us a couple of years ago about data extractivism, and Professor George Krivokovic as well, who will who will certainly look at the privacy angle of this of this discussion. So with that, let's start.
Thanks, Desiree, and for setting us up so well. And Sergio, hello. So the opening question that I have is very direct, really. What does the idea or the concept of minimum sustainable data set mean to you? Who would like to start? Sergio, would you?
Yes, I can start. Thank you. So, first of all, thank you for inviting me and also inviting me to think about minimum sustainable data set. It is a concept that unfortunately is not that spread. You don't think and hear about that much. We quite hear the opposite. So collect as much data as you can, process as much data as you can. In the EU AI Act, there is this definition of general purpose AI system with systemic risk, and system with systemic risk are those that are trained with at least 10 to 25 floating operation points. And so that means a huge data set, billions and billions of parameters. But what about making it small? So for me, minimum data sets are privacy preserving, are avoiding redundancy, and are actually good for most of the AI tasks. So sure, I don't think you can replicate the next GPT-5 with minimum data sets, but what are the tasks that we are actually doing with AI? And if we think beyond LLMs, if we think about all other kinds of applications that can support us in our everyday life, we don't need this kind of redundancy. We actually need to stay focused, and as I mentioned before, we could avoid overfitting by avoiding redundant data sets, and we could avoid privacy breaches and incidents because we ultimately do not know what happened with our personal data that are processed. We don't know what kind of personal data of us is processed. And knowing that a principle of minimization of data collection and processing is adopted, of course, can reassure us against this kind of privacy incidents where as personal data maybe in an unwanted way then are given out as an output or are a vulnerable target of cyber attacks and so on. So I see the principle of minimizing a data set size and having minimum data sets as a very intelligent principle that should guide the composition of datasets for AI application in the future.
So I have to say, like, I was agonizing about this question a little bit because I cannot really picture anything under the term of minimal sustainable data set. So is it a metric? Is it a scale that we're talking about? Like my first thought about like, what does it mean? Is it like 5? Is it 20? Is it 200,000? So it's a little bit weird. But I thought maybe we can approach it from like a very pragmatic and practical point of view. And so my background is like I do data-driven investigations. I used to do them like in the human rights context first. Now I'm having the privilege to do this like in a journalistic context. And when we do human rights investigation with data, what we try to extract out of the data is the proof or facts about human rights violations, proof of genocide, proof of like that something happened or a story of a survivor. When we do the same thing in journalism, what we try is to extract a story, a narrative, a thing of like, why does it matter? Why should the reader be interested in this story? Like, why would they give us like their time, the 10 minutes a day when they're reading news? And so when we work with data, we have like, we get data sets that are like very small, sometimes just like 100 rows in an Excel sheet and it's super simple. Sometimes they're like 500,000 PDF documents, it's very complicated. Sometimes it's like some other form of structured data and very often it's messy. And what we are doing normally is like this data set itself is not the story. This data set itself is not the human rights violation, but it contains it. depending on the question that we are asking. And so what we're doing normally is like we try to reduce the data set. We try to ask a question, and through a process of verification, we try to get to like some fact about it, some proof of like that we can make a statement about it. Sometimes we work for weeks on one data set. We extract two, let's say I have 1 million Telegram messages. Is 1 million like small? Is it big? We don't know. But like I need to extract 2 Telegram messages because then I can put like one line into the article. This is like a typical workflow that we have. So asking, if I have to ask myself what is minimal, it's basically like how much can you reduce it? How much can you focus within the data set in order to get like the answer that you're looking for? And so how I think of data is like that when I get it, it's basically just information. And it's only like through verification, through asking a very specific question to the information, you actually extract the data, you get the data set. This also means that if I ask a different question with the same information, I will get a different data set. So this is kind of like my thinking. I don't know if it fits the topic, but this is how I think about it. It's a process-oriented thing.
Nice thoughts. I don't know. I was also like really. It is kind of like mind-bending idea in a way to fit, because like if you think from the position of like I don't know privacy and all of those like things that we were like discussing in 5, 6, 10 years ago, then minimum data set have a lot of sense. But if you think from the position of AI training process, I will maybe start from completely opposite idea and try to question maximum size data set first. Like first to think like what will be the maximum size data set, and so basically even if we have, I don't know, for example, all the books in the world ever written, all the text ever, you know, like exchange on chat or whatever, all together as a data set, that data set will also not be good one, not be perfect one, because it will be representation of historical bias. It will represent who in history had computer, who didn't, who had a printing machine, who didn't, who had an archive, who didn't. So anyway, even if it's the biggest data set ever, it will be representation of power. So, and then I will try maybe to dissect from there. So the maximum one is not a good one. What it means shrinking the one into smaller one, it's again question who is going to shrink, like who will curate shrinking of the data set from everything that was ever written, no? So I remember when we were like 10 years ago or whatever, like had this idea about like okay, we want to archive internet, what will be the most efficient, like in this idea of like dark age and digital dark age, what will be the best medium to do it? And then Bruce Sterling said like clay tablets. That's the, you know, clear, you know, medium, because like we have like proof that it's 5,000 year functional. But then the question of, okay, it's not just about it, it is about like how cheap the medium is. And then, so more expensive medium it is, more you're shrinking the data set, you need to make more decisions, no? You need to curate shrinking of the data set. And then that means that the curator is the one who is going to have a power to choose what will be in the data set. So if we think about the data set as a source of statistical space that it will be created from this data set, minimum data set means less options that are created by someone, no? Chosen by someone. But then in that sense, it's counterintuitive to think that smaller is better. But it's also a question of strategy. What do you want? Do you want to be represented in a data set? You can say, okay, all of those things, like, I don't know, from the question of like any kind of, you know, like the groups that are usually not represented, do you want to participate in that game? Because if I don't know, if we are speaking about like OpenAI or whoever, do we want to make their data set better or not? So do we want to push to participate in that game and say, okay, your data set is not good and let's make more diversity and whatever and make a better data set to make your fantastic private tool to run our life, no? So I think it's also a question of strategy, like, do we want also to participate or not? I think I think if we deconstruct this, how the AI is being trained, smaller data set means more entropy, no? More chaos, more different things. Bigger the data set, it is like, but it also creates a lot of problem for us. We had like this project, participated together in some kind of research group about specifically about data set. And now data sets, and now we are in a situation what you are doing when you have 1.6 billion images somewhere, and like how the scale of data sets that are being used are now too big for us to examine, to find a way how to do, even to what kind of questions we are going to ask the data set. But I'm not so sure that the in that sense, as a strategy, insisting on a smaller is one-to-one like better. It's also a question for what, and this is maybe the problem in this sentence is like that we don't have like I think second part of the sentence is missing. Okay, you can create a super small data set for your, I don't know, noise, poetry, minimal music that consists only of one thing, and it's going to be interesting. But yeah, so okay.
1, 2. Okay, so I'll talk a bit from a different perspective. We started with this idea when we talk about data sets, we use them for generation of model, which will generate the content or something. Yeah. But in my world, and I'm a law professor teaching engineers and managers to use data, principle of minimization is like the main thing I want to teach them. And at the moment, I have like, I don't know, 4 or 5 master theses with the main topic of how to use principle of minimization, development of HR practices, of a system of monitoring of something, blah blah blah, and so on. Because I'm data protection lawyer by nature, and why is that the perspective? Because on one side, our business and organizational culture, as we all know, is based on some premises, and these premises are very simple: more data, better result. Collect them all, and then you will get somewhere. And also, if you talk about scientific method, it's very similar, regardless of the fact that we're talking about the scientific research or just regular investigation. In order to be conclusive with your argument, with your conclusions, you need volume, you need representation on a large scale. But in practice, we have this culture in organizations, both private sector, public sector, academic sector, and so on. But we tend to teach students, at least that's my role, that principle of minimization coming out of GDPR and data protection regulation is to use as little data as possible to achieve the goal. And that's really imperative imposed by regulation. So just to provide a very simple example, like you're developing something and you need age, because age is requirement to provide the service, because maybe it's born, maybe something else, doesn't really matter. But then you don't need date of birth. You just need, is it over or below 18 or any other age requirement. And then implementing in design of data sets these principles is really important. But as I said, it's different environment. It's not environment of training. Why? Because it's very specific purpose, and it's easy to apply principle of minimization to specific purpose, because then you need it's possible to play that game. When we talk about AI today, we talk mainly about general purpose AI and general purpose AI for generative purpose. So it's like we want to again catch all the potential uses and so on. And then we come to the question, as said, we are developing the model, and we need more to be able to generate better, regardless of the values we want to impose on the model. It's possible to do to minimize the data set, but that really means putting a lot of resources in adjusting the data set, putting a lot of resources in data preparation. We want to work on data structures, we want to work on quality from a perspective of truthness and verification of data and so on. So we can get the minimal data set, but then we have a lot of labor in order to get it. So we still have huge impact. And what we all know from our work, it's very nice to use unstructured data, because then you can see, can you get something out of it or not? You don't need to put so much energy into data preparation to be able to assess the potential of that data set. So maybe to stop here, then continue.
I was wondering among the people on the panel if there's anything that's emerged from what you've heard that you'd like to follow up on.
Yeah, if I might jump in, I heard a concern about an efficiency concern about minimum sustainable data sets. So I wanted to clarify something, but from my perspective, first, how small or how big should these data sets be? Maybe minimum sustainable data sets in some fields are not that small. Let's take as an example what we did in the last year with LLMs. So surely also in your working environment, suddenly everybody started experimenting with LLMs and trying out different models trained based on a different amount of parameters and data. So I recall when the first LLM services and platforms emerged, powered by different providers. I once tried out the demo platform by IBM, and also other providers started launching this platform, aggregating different kind of LLMs. And then everybody had a choice between different models. And it was very interesting to see that the biggest model were usually underperforming in certain tasks. So actually, according to the task, there is a minimum viable data set and also a maximum viable data set. So for example, those huge models based on 70 billions of parameters, you couldn't use it for basic tasks. It was a waste of computational resources and of time, because you had to do the task again yourself or redo it with another model. So it's also an optimization question. There is actually a needle size, how the model, what ideal model size should be for a certain task, and this is variable. It really depends on the task, and sometimes it can out that the smaller one is faster, is better, is more resource efficient, and this is a big deal because many companies started experimenting this year with these services, and then at the end of the month, this huge bill arrived by OpenAI or by other providers, because it's actually not that cheap as they thought. And using the smaller model also means saving more money for the same output, basically. So this is also a thing that I wanted to put on the table.
Yep. So it's a thought that also, like, I'm listening to what everybody has said. Like, I think that maybe, like, we can think that minimum, it's not less data but more compressed, and then that's a topic and can relate to the sustainability concept that we are talking about. And then in that with that idea in mind, I think the issue of who decompress, who can read, or like, then this is the issue that maybe we can think about, like, what's the workaround if we solve with the new way of, like, the data sets are more compressed and then in that sense are more sustainable for storage, then the issue of dark data, right, like data that it's missing because nobody can access it anymore because it has been, there is no key or something like that, right? So we just wanted to talk about, because minimum doesn't need to be per se less, but it could be something else.
Maybe I can add to this. So I think it's a very good thought. When we do human rights investigation, like, the point is not to, for example, verify all the data. Like, this is not a category we are working on. We are verifying enough data so that we can make a statement about it. We can make a statement of truth, a statement of fact. For example, with 1,000 YouTube videos depicting like one attack on the hospital, we have to verify 10 in order to be able to prove that this attack happened. Maybe we can prove who did it, for example, right? And the other 990 we can ignore, for example. So I think it's often about, like, we just have to create data sets that are enough in order to, for whatever purpose we want to use them. So if we create, like, publish a story in a newspaper, like, it's a different type of verification. It's a different type of, like, rigidity that we have to apply. When we produce a data set that should be used in front of court because we want to prosecute war criminals, that's again a very, very different story of, like, how we have to deal with the data and how much of the data we have to go through. But there's also the other example that I can bring. So that's an investigation we did into the ongoing war in Gaza. And, like, one problem we're facing was, like, it's very unclear what is happening when at what time, right? And so you can look on social media, you can look on media reports, but they're very, very, like, you cannot trust them. You can't read a Telegram message and say, like, oh yeah, it depicts like a tank attack at this corner in this part of the city, so therefore this happened. So this is, like, absolutely, like, you cannot build any kind of statement on top of this. So here, what we did, like, the approach that I took was, like, okay, let's go through a lot of data. So I scraped 1 million Telegram messages. If I found, like, for one particular time, one day, like 20 of those messages, it increased the likelihood that maybe these 20 messages were true. But again, like, none of them were true because it's Telegram. You can't believe anything you can read. But also, it's just you work in likelihood. And so very often doing this kind of data work, you're just trying to get to a point of, like, that you can increase your probabilities. Like, you cannot put a number to it, at least I don't, but it's more like a thing of, like, I feel like this is more likely that it happens, for example. And I think, like, what you also said, like, we should separate data sets, like, that are used for training and data sets that we actually work with. These training data sets are crap. Like, I don't know, like, I mean, I'm gonna talk about it tomorrow, but, like, I don't want to take away my talk from tomorrow, but, like, but I can really recommend you to listen to it. But I think most of the data sets that exist, most of the data sets that we actually encountered, most data sets that are relevant for us are not training data sets. They might be, like, in scale the largest one. Maybe they're, like, really, like by a massive amount larger than the data sets that we are working with. But actually, they're not the relevant data sets. Like, these large scale 5.8 billion image text pairs, these are not data sets that we really work with. Like, we don't do anything with them. Like, they're not made for us. Like, they don't give us anything. But, like, then I get, like, a data set that is like 18,000 images of birds, and that's something I can do with. That's, I can have it on my laptop. I can look on it in Finder. Like, it's not a problem. Like, so I think, like, most data sets actually that are relevant for us are not having this scale. Like, they're not affected by this problem nearly as much.
because those are completely two different, and I think it's important to understand this difference between like it's a different way of doing things. Like what you describe is looking into. So you have a data and you look into data as a human being, or even as a whatever tool you are using. You are looking into in order to find something, in order to make some kind of conclusion. But generative AI is not looking into; it's projecting from data, and that's a different, completely different paradigm. Paradigm. Different paradigm. So it is completely different thing. So you project, you take everything, you compress into some model, then you project this as a rule, as a reality. And this is like why it may be important to understand and make a difference between, you know, like data that is being used for scientific research or like investigations, and data that is being used to create synthetic models that will be used to automatize different things in our life. Because that data, you know, you when you are investigating data, you're searching for anomalies, no? Trying to answer questions, trying to find something specific. When you compress data into the model, basically it's not about it's a completely different process. It's not about anomalies anymore. It is about statistical space. It is about probability. It is about more. So you are basically projecting some kind of average image of reality that you found in data sets. So it's completely different drawing.
And then, then just to go to the regulatory side again. So I talked about data protection and privacy principles. But when you go into AI Act, the principles are completely different. So we are talking about data governance in AI Act, and we talk about the data set. And there are like 6 requirements of the data set in AI Act. First is relevance of data. What we can say it's minimization on one side, control, not all the data. Adaptation to the sector and purpose. It's again, reduce what's relevant for sector and purpose. But then representativeness, you have to go wide. Impartiality, you have to go wide. Accuracy, that's again quality, that's go control, but completeness, the 6th one. So again, go wide. So 3 of them go in reduction, and 3 of them ask, go and grab everything in the field. Yeah. So they are not completely in conflict, but in a way, 3 of these principles are requiring to catch everything representative, complete,
Well, there's a lot in that.
Yeah, I just wanted to mention something, to draw a little bit on what Sergio mentioned and what you're doing. So and what we are all here because of, right? It's civic activism and citizen science. So yes, the large models, the larger it is, the more computing power it needs. The larger the data set, the more computing power you need. And when we were discussing about minimum data set, we were thinking about all those people who would like to do citizen science, who would like to use Climeco, and who would like to enrich these data sets that they get from Climeco with the free data that they could draw from Copernicus, right? Satellite data on the weather and everything, right? And that's one of the that's where while we were discussing about the minimum data set, that's what we had in mind. So what would be the minimum data set that would need some average everyday life computing power to process and to use for your own purposes, right? And I believe, well, yeah, well, I don't have any solution, but I wanted to steer the discussion maybe into this direction.
Do you have maybe a question that would?
Yeah, that was a comment that was like a little sting to steer the discussion in this in this field where we are all from civic activism.
Maybe if I could help make the question shorter, it's like how could citizens that do citizen science somehow use these huge data sets in their home with their home equipment? So it's a real example of what kind of storage you need, because Copernicus data set is huge, but you want to question all of them.
Does anyone want to respond to that, Sergio?
Yes, of course. I mean, it's not a kind of endeavor that normal citizens alone could strive. So this is actually a political question. So how do you make data sets for the common good? And I met Desiree at the Global Solution Summit. It's powered by the Global Solution Initiative. They were writing very interesting white papers about data commons. And this is something that we have just in very limited application fields like research. And the idea is that we will need data commons in way more fields of application. And these data commons then will be at the service of the citizens, that there will be a public good that people could use for their application. You cannot expect from everybody to be able to use data common, but there will be available public data that could be used for public good. This is a collective endeavor, and we do not have it. We should have it for many application fields, and I think that's something that needs political support and needs collective aggregation by the citizens.
Much. Are there any other questions? Any comments from the floor? From the
Maybe I can add to what Sergio was saying just now. Like, I think availability is very, very important, and I would add to it, like, what is also important is transparency into the data set itself. Like, it's not just that we need to be able to get the data, whatever technical means. Like, it can be nearly impossible, like Copernicus, or it can be something much simpler. But to know and to understand what is in the data set and why it's in the data set, like what was the process of curating the data set, I think that's actually the interesting question here. Like this, because this decides, again, like I would put out a hot take now, and I would say like that bias in data is not related to the size of the data set. It has no connection to it. So where the bias is coming from is in the process of curation of the data. This is where the bias goes in, and then the bias of asking the questions and how you ask the question. But the data set itself, like the size of it, if it's like 10 rows of data or 8 billion rows of data, like it will not make a difference in terms of bias. So I think like transparency is like the one important thing we also have to add into this list of availability.
Yeah, I think the issue of disinformation that came up earlier and the potential for it to just grow and grow. I was reading recently a Google paper that said that, really improving prompts and learning using something called chains of thought, which can link back to things, but it only works with large-scale data sets at the moment. So that leads to the question of, do you need to go big in order to ultimately improve the data responses from the learning models, which I think is a really challenging philosophical paradigm, practical one at the moment for all of us to grapple with. In a way, talking about the size of the data set is talking about it's only one issue, because what this goes back to is efficiency of the system and actually, doing stuff. It's not just the data set, it's actual, operation.
No, yeah. But I think we are entering into some kind of trap of again this kind of techno statistical solution. So like this idea that there is a proper data set, there is a proper machine that will do something. There is, I mean, I think sometimes we should like ask, do we really need that machine? Especially generalized machines, like big ones, like the general AI that will be applied to the whole humanity and everyone is going to use it. You know? That there is no chance that that one is going to fit all, because it will come from some kind of data set that belong to some culture, to some company, some whoever, like whatever combination. Really small chance that that will go well. We are going into that direction, and this is like I think the core question of sustainability. It is like really going into this kind of like again, like this kind of like who owns the tools of production, you know, like whatever, if it's one tool owned by one company or 5 of them or whatever, it's not going to be good, and the size of the data set, it's not going to help, you know, with that. Maybe some kind of decentralization of I mean, we have to have like some kind of a lot of specialized tools that will be specialized in certain things, and they rely on certain data sets. But that's a probably better option, no? Than to have everything in 5 companies again. No? Then the problem now, we are not even like who have. This is also a question: do we really have a capacity now in this moment to compete with that? Like, who is going to do that? Who is going to pay for that? Who is going to pay this electricity? Who is going to, like, I think that the threshold, it's already really high. So, but core down in the before we start to question is any data set can be without bias or whatever, is a deep belief in a quantification and statistical understanding of reality. Because now we are building large-scale machines that are going to automatize statistical decision-making and statistical vision, statistical thinking, or whatever. So I'm really for this kind of hardcore investigation of statistical logic at all, because like most of the statistical logic is based on a certain functions that if you think about them in a political context, they are totalitarian functions. Bigger, better, populist, totalitarian, statistical future. It's what we are building. And it's not so sure the scale of the data set will solve that, but like maybe rethinking, that's not going to happen. Anyway.
For the conclusion, maybe just to reflect on 2 points. First one, the scale of data set. We can go minimal when we talk about number of data points. But then each data point has to be described really well, and the relations have to be put in a good order. So then we have another layer of data. So there is a balance between these two. So we, regardless of the number of data points, is it 1,000 or 500 photos in Bird's data set? If they're very well tagged, maybe 500 will work really good. Yeah. But then tags are also data, and like we have to calculate which kind of data are really minimal and not, and so on. But the other thing, when we go into AI, what Vladan said, but just to reflect on that, and with what I started, if we have a culture of tools for specific purposes, then this idea works. If we have a culture with a general purpose, catch-all solutions, one tool everyone can use for everything, then it cannot work. So that's really a question of culture and how we distribute the market and how we create business models and so on and so on. So I think that's really for thinking, do generative general purpose AI in this phase of generative AI is something what we want to make as a rule in our society.
maybe I could reflect before you close as well. I think we open up a lot of good ways of how to think about this concept and what's useful and what's not. And, you know, just rethinking about all these questions that we have here. To me, it bears even higher questions like, is digitization or all this digital transformation that we are seeing really is going to put a society on this transformative path to sustainability or not? And what are the right things to happen? And certainly Sergio mentioned one of those, like digital commons, where the internet users are going to be part of that conversation rather than 5 companies doing that. Then there's a question of open source license as well, whether these big 5 companies will outsource it or keep some coggles to themselves. So yeah, we open up a lot of questions, but we also manage, I think, to dissect some ones that are bugging us. Back to you.
Good. Well, as you've said, you were the one who set us this task, and you seem reasonably happy with where we've got to. So on that basis, let me thank all the panel, including Sergio, for wrestling with this. And also thank you all for listening.
Thank you.
Thank you, Sergio. See you online. We have some drinks downstairs, I think. And we are done for the day. So happy us.